Hello! I'm late again. Yeah. Who is there today? I need to rotate this a little bit. Okay, no lavalier microphone today because we had some noise last time. And I will just keep it to this one here and I hope it's good enough. Hello Buttermaster. Let's check who we got in the chat today. We have Christos, Jay, Maiko, Johnny, Moritz, did I miss someone? Christian, Vasilis, Dominic, Electron Ash, and Jay Rogozinski, Matthias Süß, and everyone's watching. Wait, I see we have 7 viewers. So actually that have been all. Okay. Yeah, I scheduled this spontaneous stream today because I was talking to Christos today, and we were finalizing the design for the Power over Ethernet's Raspberry Pi board. Here it is. And we had some bodges already. We fixed software issues, or let's say hardware issues in hardware, and we need to flip few pins like USB and stuff. And there is still one thing that we want to address today, is that we got this we used this GitHub code for the Ethernet IC, and this is using the 50 megahertz crystal clock from the Ethernet IC and not the 12.5, I think it's of the Raspberry Pi itself. So the Raspberry Pi has to underclock and use a different clock source to be able to communicate over Ethernet. And this is something, David asking if there is no food cam. I will come to this point in a second. Okay, so the question is, we have an option. We did an option on. Can I turn on this camera? Maybe I can show it on this extra camera here. GH5 is this? Oh yeah! Woo! Haha! Oh! There is a spoiler. Okay. Here. So, during this design, Christos and I, we weren't sure if what kind of clock we would use for the Ethernet pin, and there is we have a jumper here, and if we can use this jumper to change the pins on the Raspberry to maybe put out a different clock. So hide this. Put a different clock, let's say, from the Raspberry to the Ethernet IC, and not using the external crystal. That would save us a few parts, and we would use as the same clock source as the Raspberry Pi initially. It arrived. Oh no! Did I spoil things for you? Did I spoil things? Did I spoil that we got fresh fondue here? let me turn that on. We have also bread with this fondue. Zoom back now. It's the furthest I can. And this is, I bought like a bit of confusing one, because this is produced in Schweiz, in Switzerland, but it's coming from Nuremberg. So, but it's actual Swiss fondue. So this is the one that we want to try, and I only ordered from our fondue fund. We ordered 6 packets, so this is the first of the 6 that I will test for you today. And if it's no good, then we only need to eat 5 more, and if it's good, I can reorder basically. So yeah, thank you for all the donations for the fondue fund. And I also ordered pink LEDs, 0603, a complete reel of 4,000. Let me show it on AliExpress. I bought it from AliExpress, so that will take a while to arrive. Where is my order list? My orders, I can share this with you. Capture is on. Oh, that's the code. Oh no, my screen is still at 4K. You won't be able to. I need to change the resolution. I hope it works. Okay, here we go. Here, yeah. Since I'm streaming in HD, this is where I found pink LEDs for $11.80 plus $6 for shipping. Not sure if it will arrive, if it's any good or whatever. We will see. So I don't know what we do with 4,000 pieces. I will never be able to solder them by hand. So that's basically a waste if I'm not using my pick and place. But nobody will ever complain anymore that I don't use pink LEDs. So that's that. Oops, that's not what I wanted. I want the face cam. Woohoo! Here I am. Screen capture. Now I can also change the resolution of my. Before we start coding, I can change the resolution of my screen to HD only. Whoa, yes, I accept. I hope OBS doesn't crash on me right now, but yeah, keep it like that. Okay. Woo. Oh. So what is the chat? What are the opinions here? Quindor is here. So who is hosting MakerCast on Sunday? Do we have a link yet? Did you order 100 packs? Yeah, unfortunately, Maiko, 101. That was like already a cheap fondue. With shipping, it's like this was like 5 to 6 euros per packet. So the fondue fund still like covered the few parts in the future, but to order 100 we need like 600 euros, and I don't think that I can eat. I will die if I eat 100 fondues within the time that this is like not spoiled. So Oh, actually, March 22. So this phone did 100 packets, that's one packet every 3 days. No, not. Yeah, almost like I have to eat one packet every 3 days to get it done. Poor girlfriend tonight. What do you use? Okay, cool. I have a file coming next week. Is the PNP working alright? Oh yeah. Yeah, probably. I didn't change anything on that since I last used it. Before you finalize, I say research how not to connect cable connector shield. What? What are you talking about? Oh, the chat is very active right now. Let me just start coding, then you people will fade out quite quickly. Hello, David. David Boyd is joined. Might I, if I eat one of those packs? Way past my Ash. Why that? Are you like not very well digesting cheese or what? The cardboard is very nutritious. Oh, not a quiz master, Dave, this time. Yeah, who is hosting? I missed that. I have genuinely had way too much cheese in the past few months. I have cheese on toast for breakfast quite a few times a week, and then too many pizzas. Oh, Quindo, okay. That's cool. Looking forward to it. I will, as soon as you got a link and we are ready to announce it, I will share it on my like idlink accounts. I'm eating cheese like almost every day of the week. I have cheese every day, I think. It's like butter, it's the base on my bread. Let's check out how the fondue is doing there. Ah, it's a little bit cold. Let's stir it a little bit. Fondue. Yeah. Okay. So what I still didn't manage to do is to find my temperature probe to test the. So yeah, what we have to do, what we want to do today is to test the clock source. This is my #1 priority. If we could actually fix that and maybe even run the Raspberry Pi in its original clock setting. I have no clue how to do that. That will be like some boring discovery here. And then I wanted to test, oh yeah, we have to test the ADC. Oh, the reset button is broken. I can show this. So you see that button here that fell off last time? I will replace it quickly. Good quality button here. I can remove those extra pins that I've used for probing the power. We don't need those anymore. We can even add some pin headers, but I don't know if I want to use like those double thingies or just the ones that go down. So we have like, it's not populated yet, we have like a voltage reference for the ADC here. Christos was also mentioning that today that we should test it, and I agree on that. There's probably like an ADC example in the codes, the Raspberry Pi SDK. We can check it out. That's quite simple. And then I wanted to test the heat on like different current draws. So if it would disorder itself at some point. Squeaky chair, yeah. I hate it. I try to, maybe we can fix it. It has a cover. There is a plastic. I don't know if it's. How? Where is it? They're like. There's like some silicone. I might try doing that. Fixing the chair. You want to see that probably. I don't know. You came here for the Raspberry Pi development. Now we are fixing a chair. So what is squeaking here? I think that is an axle here. Yeah, this is like completely enclosed. I don't know how to reach that. Okay, here is like I can't even see a screw there. How do I know that I had to put this thing just on. Stupid chair. Yeah, but I don't see anything here. Maybe I just try Phillips screwdriver on that. Oh yeah, that fits. Brian is here. Okay, so okay. How do I got 2 screws and this is quite dusty. Oh, maybe I should blur the camera because of all the dust that's in there. Is there a... Oh, there are more screws on the other side. Yeah. That's my life. Always distracted by other stuff.
But how do I get there? I can't get there. No, I can screw that. I could do this. Maybe I can bend it away somehow and get there with the spray. I can hear the fondue boiling. Ah, no! I need to get there somehow. Is there a way to get there? No. No, I would have to disassemble it completely. Shoot. Okay, let me just spray there in somehow. And let's see if it fixed anything. It's worse! But I can, it's only down there. Maybe we are close. Give me one more minute. Okay, that's even worse. Okay, no chance. Ah. I rather take care of my cheese. No, I never run over my toes. I just step on small microcontrollers. Solder-proof hairstyle. What was 1,000 euros? No, the chair was 150 or something. It's like stepping on the package hurts. Yeah, yeah, the pointy ones. Yeah. Okay, let's test the fondue. Oh. The consistency is okay. First impression had something like of a rubber, but let's not be too quick with the judgment on this. I think I might need 1 to 6 packets to
have my final judgment on this brand. Oh, Johnny, your chair was 1,500. What is this made of? Gold? It has probably like some. It's made from gold and has imprinted a record of all the sounds of the planet, and you can put it on a space probe and send it out of our solar system. Maybe Deutsche Mark. Oh, I missed the cheese. Just remembering this horrific sushi that we had. It's very mild. It's not like super strong taste. Get a chair from the 80s. Yeah, if you get a chair from the 80s, then it's probably lasting long because you were able to get it from the 80s. So it lasted until now. It will last probably a little bit longer. I had a bunk bed in the 80s. I had to share a room with my older sister back then. This is like the first years when we moved to Germany. It wasn't easy to get like a flat. Oh, this is so tasty. I love cheese. Okay, let's concentrate on our work here. First of all, we make sure that it's still running. I will use the tablet to test it. So we'll run it from power over Ethernet here. And connect. Okay, let me share the screen. We make a small screen here somewhere and put it above like that. Okay, what was the IP? 102? No. 102. One 101. I need tel. Oh, it's not connected to telnet. Let me check. Manage router. Okay, we have 100 is the current IP because we were first to sign in. I should basically make it fixed there for this device. Okay, it's still running. This is the page it's serving right now. Now, what we want to do is you guys still talking about the 80s? The good old 80s, where I watched like a recording of Short Circuits like 1,000,000 times, or Karate Tiger. What was the name again? I really thought back then that Johnny 5, no, the other one with Jean-Claude Van Damme, Brian. We had this topic last time. You probably missed it. It's like yeah, U5. I thought that the robot was actually working like that, but it was more or less a puppet. There is a CNC channel that tried to rebuild one. They make it like a community project where all the machinists from all over the world are sending like a small part. Your streams are longer than time itself. Yeah, my streams are proof to relativity. Yeah, I saw. I watched. I think I watched the making of. It's quite rare, but I think it was on YouTube as well. Hello, Dustin. I will be done with the fondue before we even start to do anything in the code. Okay. First thing, I forgot that we need to replace the reset button, otherwise we are not able to program it at all. So and this button is broken. I will basically just reflow a new one on top of that. I think I might. Does any one of you watch Julian Shorts? How is that working? I was thinking if I might try either create a short channel and try to make a short each day, or I put the shorts on this trash channel or on the main channel. What is your opinion on that? I don't want to clutter stuff in the subscription feed. Where are the buttons? You may also make TikTok instead. Yeah, but TikTok is like already, I have a TikTok channel and I don't do anything there. I could basically do it in parallel because where are the buttons? Strange. Okay, to be honest, I also didn't upload anything on TikTok for a while now. I never even installed Snapchat. There is a chance that basically there's like this gold rush for this new feature. You always should go for new features. Okay, it's not very new, but I think the more acceptance it gets on YouTube might be worth a try. What's this? I don't get the point of... Yeah, Henrik, I'm watching. You should try TikTok and try first to. You have to condition it to your liking. So like search the right terms or fave the right post. For me, it's quite political, funny, and I also discover makers there. If you're like in bed and don't want to get up, or if you are on the toilet or whatever, it's the best to just oh fuck, I dripped on my pants. And oh no! Are you invading your LED stuff in my stream again? Ah, this cheese is so great. I still need to find the buttons. But I should have a reel of similar buttons somewhere. Nope. That should be all components here. Oh, here we are. We can mine bitcoins for Dave. Don't demonetize. Uh-oh. Uh-oh, I hope. It's past 8, so kids should be sleeping right now. We should never suppress our feelings, and in that situation, that was the expression of my immediate disappointment. Okay, maybe we should also let me check the. Let's take a look at. Oh, this is not it. We don't also show everything on the interwebs. I need to check. Oh yeah. Maybe we should hide this and check what we need to populate for the reference, the voltage reference here, because this is the only thing that we didn't populate yet. So I will just populate it as well. So we got this off the table. Now that we are switching to the other one anyways. And this is basically LM4040, okay, let me check that. Oh! Ha! First component in my hand, LM4040, okay, we got this. And 300 ohms. Oh, yeah, here, the second component. Cool. And 2.2 picofarads. Okay, I need that somewhere. That's 22. That was quick. Hey, Bolukan. 2.2, yes. 2.2 microfarads here. Nope. 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 470. Nope. 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 And nope yet. Nope. 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 We got no microfarad? Yes. That's it. Okay, I found it. Cool. We got the components. Maybe we need some headers as well. So what kind of headers should I use? I rather like to use, we can use yellow ones or black ones. Or should we use like this, these, the ones that, now we will use black ones or yellow ones? Your pick. Which one? Black, yellow, yellow, pink ones. Ah, no! We might have enough to get pink ones from AliExpress. I think the LED phone would cover that. Let me check. Pin header 0.1 inch pink. Okay, so let's look only for pink. Let's hope we don't get like what? No. Oops. Uh-oh. If anyone, oh, there are some pin headers. These are even stackable. But what colors do we get? These look almost like pink ones. Blue, red, no, it's red. It's hard to get any. If you find another source for pink headers, please drop me a link. I will try to get them. Okay, so we had like yellow, yellow, yellow and one black so far. Okay, yellow wins then. How many do we need? Okay. And this one. This will be cool. I never saw this board on a breadboard before, so we got a yellow one. We will do a black one in future as well. Oh, the chaos here. Oh, you got some? I will switch to the microscope. Pew, pew. And I will check. Bolly. These are like 1 kilometer long. Long. I will add them to my favorites, to my wish list. Bolly, you got ones? You got some different colors. Which one? Okay. Oh. Okay, there's only red. Ah. But the Chinese red is really looking like pink to me. Wait, here we go. So this is really looking like pink, not red. This is like pink. We need the pink master to decide. Yeah. No, they are red, trust me. You ordered some? Really red? A reddish red? Should I test it with a color picker from this image? Let me... Where's the color? Ah! Okay, so this is actually pink, isn't it? If there would be like a tooltip for this, it would say pink. Should we just order to test it how pink it is? Johnny is... Wait, what? I can post a photo, but it's the same red. Johnny, what is your judgment on this red? Is this red, or is it accepted as pink? Where's my fork? I need fondue. I lost my fork. That is not pink. What do you mean? What is... Ah. You know that I'm colorblind. Don't fool around with me, because I am confused afterwards. I will doubt my whole life after this. That is red. It's red. So pink is like magenta for you? Or what do you see, Discord? Where on Discord, what do we got there? I don't see anything on Discord. Oh, my mouse is dying again. You guys are fooling around. You would need like 10% more. So okay, then please teach me. Okay, I'll please teach me what is pink and what is red. So let's do it. Let's do a pink or red session. Let me use the color picker. Okay, then let's use brush. What color is this? Vote. Red. Very red. This is very very red. That sounds like an invented red color from Apple. Very red. Okay. Then what color is this? Dull pink. What color is this? Dark pink? What color is this? What color is this? Can you mark me so I can post the link? Yes, Jay, wait a second. Here. You can post links now. What color is this? Oh, I should check this is? Okay. Oops. So this is pink from Wikipedia. My favorite pink is F06. Okay. What color is this? So, oh, this is the pink. So it's something between pinkish red and magenta. Like pastel magenta or what? Is pink? Oh, I'm so confused. So this is actually okay. So this is red. This one here in the center. I have a color sensor that can measure the red of these headers. Do it then. The square is the pinkiest pink. This is similar. This and this. Okay. Okay, I get what you mean. It's like more towards magenta than towards red. Or yeah, it's somewhere in between. Between magenta and red is pink. What color do I see? I see the same color as I see always. This is like the color that I see RGB with like full red, like 1/3 green and 2/3 blue. That's for me what I see there. I don't see like a specific color. It doesn't say a name for me. It's just a mix of 3 base colors, and I need my fork for my fondue. I lost it somewhere. It's cooking, but I don't have my fork anymore. No. Did it drop on the floor, or where is my fork? Oh, here. I found it. 2/3 blue, yeah. Barbie pink is what. But you realize that pink isn't a real color. There is no pink in the rainbow. Jay, you mean Enchroma? I got a pair of Enchroma. Let me grab my Enchroma glasses. I think they are upstairs. I will grab my Enchroma glasses and I will check again, but they won't change anything because there is no real pink. Yeah, unfortunately, I think my glasses are in the car. Or do I have? Oh, they are here! Ah, they have been here all the time. So these here, I got them when I was on the Hackaday Super Conference because they are quite expensive if you want to import them to Europe. I don't know if that changed in the past years, but if you want to buy a pair of these here, you would have to pay, like with customs, 400 euros or something, 450. And I didn't want to order a pair without knowing if they even work. So I got them directly in California, where the company is that produces them. And I don't see, like, there is nothing new that I see with the glasses here. There's no change. It's not a real color. Hold it. So they are really hefty. Like, this is like a filter. The problem with holding it to the camera, let me check on the other camera, GH5, that they are quite hefty. Do I have like an Ishihara test? I have an Ishihara test somewhere. Let me grab it. Where is my Ishihara? I will be back in a second. There is a chance. They're boomer glasses. How do they work to me? Okay, so the only thing that I noticed. Okay, so I must say, it was a good decision to not buy them here in Europe because this was in Beverly Hills, because this was the only shop that had a pair on stock. Dr. Bradley, I don't know what his name is. He had a pair for me, And he let me just walk out with these on without paying them, just to test them outdoors, because he was curious if they work at all. Because he had just them put on stock in his like shop there, and I got them for like 200 or something. I got a huge discount. It was maybe $240. Yeah, it was really close. 90. I can't. No, I don't have the packet, but it was like really Beverly Hills 90 to 10. It was like really close there. Yeah, Dr. Bradley Richley. Yeah, that's the one. That's the one. I got my glasses from him. And that's like Beverly Hills from the 90s. This show. Yeah, but I got them for $250. So, and I don't think they are worth it, because they are really nice. So the difference for me is that, for example, surprisingly, the yellow is really like popping. And you have a time to adapt to these. And but I'm not able to see more than before. I wouldn't be able like to maybe a little bit. So maybe I have like, oh, interesting. On the screen, I see the 8 better than I see it in real. So with the glasses, I can barely see like there is an 8. Without the glasses, I would think there is a 3. Whoops. Yeah, there's definitely a difference with the glasses, but it's not huge. It's like maybe 20% or something. So there is not much with this notch filter. Yeah, it's an 8. There is a 29, yes. It's mirrored. Oh, wait. I can mirror that for you. No, it shouldn't be. Wait, is it mirrored? Yes, it is. Why is it mirrored? Oh, sorry. Ta-da! Yeah, that's a 29. Okay. Yeah, but it's easier. I see it's easier to, with this camera, it's easier to see that. I don't know if this camera, oh yeah, it's even more. Like I wouldn't be able to see it in, that's like an original, I think I paid even 200 euros for this original Ishihara test from whenever this is. This is like a super old test. I'm not sure how much I paid for this original Ishihara test, because I was really curious and I wanted to make a video on that. Why are we here today? Okay, hear me out. Hear me out. Since we have like the majority of you are men, there is a chance that one of you has the same like color vision problem that I got. Like deuterium are 10% of men. Yeah, this is the 12. This is the one that we got. This is already hard to see for me. I'm not able without glasses. I'm not in real life. I'm not able to see much here. On camera, I'm able to see the two and like the shape, like the outer line of the 9. Then we got something here. I see that there is something, but I wouldn't be able to say what it is. The 5 and an 8. No, is it a 3 or 8? I can't tell. Even with glasses, it's hard for me. 15, 74. If you have a problem to see the numbers, 71, 74, 74 it is, I think. And this year, it's impossible to see anything for me there. It's like, I have no chance. With the glasses, I can see a little bit. Like, there is a shape. Should be a 6, yes. But the 45, I couldn't tell. It's like, okay, 5 and 7, I can see those. But not in real life. So here is where the glasses make the most difference. Maybe I can show with glasses on what happens there. Look at this. I don't know but I can tell the difference there. I can clearly read the 5 and the 7 now, looking at the screen, but not like this. Maybe the 7 a little bit. This is the difference with glasses. The 12 was easy for me, these are harder. Yeah, so there is actually, you might have a problem with color vision as well. And yeah, this is where I get lost. It's like harder and harder. Here. Oh wow! Okay, that's a 16 and that's a 73. That's a notch filter working here. But it's like in real life it's harder than on the screen. It shows better on the screen than in real life. So. And here there is like basically some shapes. Here's another one. Oh wow! Oh, I can't tell what the second digit is. 26 and 42. I can only see the first digit here, even with glasses on. Yeah. With glasses on, I can only see here's a maze. And what is this? It's nothing, is it? Just a test? What is it? I can't see there anything. Intestines, warm. Same scriggle? What? I don't see anything there. Oh yeah, there's oh, maybe that's for kids or people. Oh yeah, I can see this on the screen now. Okay, yeah, this one is obvious. And here's some hard one. I hope that nobody of you had some bad news right now watching it. Testing the Ishihara test here. It's red, I'm not colorblind. Wait. You had problems with one of the plates. Hello, Simon. Yeah, we are testing colors. So there was like a sidetrack because a short distraction. Medical you think you need a medical disclaimer. So, disclaimer. These glasses here, these Enchroma glasses, they're quite expensive for what they do. I enjoy using them like in summer outside. These are like good, basically shades. And that's where I use them. And I'm not using them like the whole day because it doesn't make a huge difference for me, actually. I'm like really, really green blind. So even a notch filter only tickles a little bit those receptors that I have there. This is the official, yes, that's like the super made in Japan. That's the original Ishihara test. Yeah. That's really the reference of the reference for those tests. Yeah, random hacks. That's true. Oh, Japan. Yeah, it's Japan, so it's quite expensive even. A microscope is, it helps much more with the vision than the glasses. But if you want to buy like sunglasses for $200 anyways, and you are in the US, you should maybe try them on, because they are good sunglasses and you get like this extra notch filter there. Okay, so but this pink, okay, back to the pink issue. If we, let me check the color. We continue with the other stuff. You're confusing me with the color stuff. Okay, so this is like the most pinkish, that's the closest to the pink. Let's get the color picker. This is the pink. Yeah. This is the pinkish pink. So let's make this pink become this pink. So we want this color to become this color. That's actually quite easy. We make this background. This background should make this pink. Wait, no, less saturation. Is it pink now? It just needs to be like, if the surrounding, like the white balance is like off, then you think, or is it no, still red? It's even more red. Okay, then let's make the surrounding like this. Or no. What is the complementary color here to make it pink? Not even close. You guys are killing me. What's with this? Is it pink now? It's quite pink, isn't it? It's so pink. It couldn't be more pink than that. It's like super pink, isn't it? Just look at this. How pink it is. It's so pink. It's orange, still red. Okay. Okay, I give up. I give up. You send me a link to pink pin headers and I will order them. Other than that, we will just switch to the soldering station there and put on some some components. Dark pink. Oh, there was a dark pink. Andy! Yeah, you're on my side. There are no pink headers, sadly. Okay, maybe you ask. Lila. It's too pink. Okay. Maybe it's only a matter of the source. Maybe we can source pink headers from China. We just let them injection mold pink headers for us. How about that? I think Johnny and Dave would be like up to it to make it happen. We just contact the like some manufacturer and say we want pink headers. So I was talking to Isla recently because they want some sponsored content with my channel. And one of the things that I thought we could design is a badge that basically says pink. And it's full of pink LEDs and somehow driven like with what's the thing that we are using, Dave, Darko? This here is where we want to go. Oh, I think we have even the component already there. Or where's it? No, here we got some. There is a cap. Yeah, that's the reference and the cap. Like that, and let's solder it on. Oh, which internet provider? Sorry, Simon. You should address me directly at bitluni /, so it will highlight your question for me. I'm using Telecom. That's 100 megabit DSL, but I got like 40 megabit. No, it's like 20 megabit upload, I think it is. Or is it 40? It's like really, the upload is really good. No, I think it's 20 megabits upload. Is it? Yes. So we can test. Oh no, we can't test while I'm streaming. That would be horrific. But I set the stream quality to 10 megabits. I don't have fiber here, unfortunately. Only green PCBs? Okay, then we need to make a project which says only green. I'm eating again. We wanted to solder something here. Okay, let's solder on some stuff. Get the voltage reference here. The button. This is 300 ohms. And this is the cap. Okay. Oh. Let me check so I don't solder it wrong. C22 and R18. C22 R18 and C22. Okay, so the cap is at the lower spot. Is there even a flow? That's a little bit too much. This one doesn't like, okay. We need to be careful there to not to destroy our USB. Oh no! We lost the cap! Where is it? What? Where is the cap here? Here was the cap. I need to look. We have some traces. There is a trace. Okay, where is it going? Huh? Wasn't there a cap? I lost it. I can't see anything here. Let's change the switch. It's basically gone. I need to check what we lost here. Oh, I found a stray cap here. I don't know if it's the right one. You lost it ages ago. He's dead, Jim. Yeah, it's a 4040 voltage reference. Okay, let me check what we lost here. We lost... Oh wait! It's the same value! 2.2 microfarads. All the three caps are the same value. Oh, thanks Christos, that's like quite convenient to know. Okay, cool. I can basically use the same cap there. Wait, what? Every time I bump a component on the table, I'm not sure anymore which cap it is, so I just grab a new one. to be sure that's the right value.
Oh no, it flew away again. Where did it go? Here. Found it.
It's like a very constrained space here. Okay, let's leave it and solder by hand the rest. I used the hot air station just to have it flat on the board. Oh. Yeah, that's quite a blob. That's good enough. I don't like how this one looks here. Flux changes everything. Our bodges still working. Okay, we have everything populated now. This looks like really shady here. Okay. Oh, I wanted to remove this here. That's the worst. Like, how do you clean up a closed hole? We try wick first. The magic of a solder wick. No? Didn't work. It's like ground plane cooling here. Not working. Let's try this one with this pistol directly. This is the only case that I'm using these. Done. Okay, let's add some pin headers, shall we? If it fits. I'm not sure if I need to heat it up a little bit. Otherwise it won't fit through the hole. This one is still tight. Still too tight for the header. Fortunately, it's only one hole. Okay. Went through the second one. How do I get the right distance there? Let's take 2 more boards. Oops, wrong side. Like that, and hope it's more or less straight. No tilts or anything. What is this? Okay. Oh, there was some kind of a hair. I need some more. Okay. Okay. Everything else in place. What should be fine? Should we ultrasonic it clean? Let's do that shortly. I can grab some cheese while we clean it up here. I think I burnt myself a little bit. Days since last accident 0. Here. What? How? Oh, that's not that bad. No. Not this. This. I think we have everything. Simon, yes, I have planned doing some more. Oh, I messed up here. Do some more stuff on driving things. Like, I have all the parts already here. I just need to do it. Please update Discord now. What should I update? What? The soldering gun. No, I think I just... It was like in the last second. I think I just touched myself with... I don't know what. Maybe it was even the microcontroller itself. I don't think that can damage the ears. It sounds much louder on stream, on microphone than in real life. At least I'm not able to hear it anymore. Or not that badly, because I have my tinnitus already. So story time. I got a tinnitus from Prodigy. I was, with 18 years, I was on a Prodigy concert and it was so full. It was in Offenbach. It was so full. I was like in the first row, directly in front of a speaker that was like 3 times as big as I am. And it was blasting my ear. I didn't have any fun at all. And afterwards I realized that I lost a lot of my hearing. So thank you, Prodigy. Never go to a rock concert without hearing protection. Lessons learned the hard way. Oops. Interesting. I dropped cheese on my keyboard. And cleaning it up triggers some functions here. Either I just deleted something or disabled layers. How do I open it? I think I just disabled layers, yeah. I don't know. Cheese everywhere. Just slurped. There is a undo list. There's no undo. Oh, there's so much goodness left. Cheese goodness. Okay, I think the IPA evaporated. We can test if it's still working. Uh-oh. It doesn't. What? It doesn't work anymore. No. Look. Where is it? Here. It's only like blinking. Focus. It's only blinking red. It doesn't work anymore. I broke it. It's dead, Jim. Shoot. What can it be? Let me try USB. Okay, USB is working. No. Let me test if we got the server connection. Should be there. It doesn't boot. I see it on the DHCP, but I don't see the server running. Need to test if there. Johnny's suggestion where? What did Johnny say? Reset button. No, reset button. There is no way the reset button can be soldered a different way. Let's take a look underneath the on the microscope what we got here. What's going on there? Otherwise, we can also check. What's wrong here? Ay. Maybe there is like. Good guess, yeah. Switch 90 degrees. There is no 90 degrees for this kind of switch. Look at this. There's no way. Funny thing would be if it's actually 90 degrees. Enhance. Yeah. Okay, I zoom out a little bit. Let's check if there is like a stray cap somewhere causing a short. Was this populated before? Okay, the only thing that's new is the voltage reference. Should I take it off? I don't think it's like this 300 ohms. This could be also the problem, but let me take that off and see if we have a change here, a difference. Very delicate otherwise if something like that breaks it. I don't even see red now. To the buck converter, stray cap. No, there is no. What did I break? USB still working. Oh, I need like this thermal vision camera to see where it's heating up or anything. PoE injector messed up. Oops. Now the Raspberry is still working fine with USB. Oh! Now it's working. Okay, let me put it back on. I think it shut down somehow. Huh? Now it's not. Oh, now it turned on. It seems to be okay. Okay, turned on again. Okay, this is working. Let's put on the reference. I hope this is the reference. It should be. I'm lost. Okay, good enough. We didn't change anything else but the reference. Let's try again. Nope. It's a MOSFET. The hidden IPA finally evaporated. Bad contact. Yeah, I might be. Maybe it's a MOSFET, not.
Let me check the component numbers here.
If it's a MOSFET, then it's in the wrong bag. It says LM4040 It's a MOSFET? What? Insights Jens, create a prototype. No, it wouldn't. It's much more fun to debug it now. It's a MOSFET? What? IPA is capacitive. If it's so sensitive, then I don't want it to work at all. It's like so sensitive, like indoor plants that are allergic to tap water. I don't want to design a board that is upset if you put IPA on it. So RKE is the label. RKE. I test if the label of this component, if it's the right component in the right bag. Let me check if it's the right component. So it's from Mauser, it's the LM4040 EIM 330 N 0 PB. Biodegradable board. RKB. It's the right one. Some connectors and stuff are not supposed to be ultrasonic clean. What? Okay. You know what? I'm for like Darwin in this case. If it doesn't survive ultrasonic cleaning, then it shouldn't be there. I want it off my board. Maybe I wouldn't put TFT displays in the ultrasonic cleaner. It's RKE, I think. Where do you find this? Can someone post the link where you find it's RKE? Where do you find the reference for those components? Now we would need a Fruchtzwerg to analyze why it's not working. RBMK, Chernobyl Reactor 4. We are just creating trouble for ourselves. The more components we are using, the more 3 volts is wanted. Thanks, Ash. I should point out that there is like probably another stream. Envy is probably streaming right now on Twitch. If you're bored by this stream here. He's doing some design work, I think, to get the right spacing or enclosures for his LED stuff. Hello, Christopher. So I need to check. That's so tasty. I need more bread. What does the voltage reference do? The voltage reference, let's check out our schematics. The voltage reference gives us a precise 3 volts reference to the RP2040. So we have a reference going in somewhere here. Where is it? Here. So that's just a reference for the ADC to get a precise analog reading. Oh yes, make a cast. Please follow it or click the notification button there. Let's check if we got the right connection there. So this is if we are using the right legs. Maybe we are different way around or something. If we got it wrong. View data sheet. Oh, it doesn't show. J. Oh. Oh yeah, that's the adjustable version. Which one do we have here? Maybe we got the wrong version here. No. Let's see at the labels. No. Yeah, that's the 2-pin version. And that's right. We just need to know if it's the adjustable one. No, the 4041 is the adjustable one. Okay, so it must be this one here, and we want this package. So the lower pin to ground, let's just check, this is ground. Okay, let's check on the board. This is ground, yeah, that's right. Everything okay here, and this is just pin, and this is the reference. But it's, again, it's a diode. It's the same problem like we had with the other one here, with this one here. This was also a diode. And it prevented it's upside down. No, it's not. Look, look, look. It's rotated. So this is ground, this is voltage reference, rotated by 180 degrees. Here, ground. This is correct. I show you. Snipping tool. Snipping tool. Then we need, and then we, oops. We got this here. So if the IC is this way around, there is minus, there is plus, it's pointing towards the plus, and just to make it like foolproof, not that any one of us would be full except for me, and this is basically ground. Let's check here again. Reference circuit. Here, the white side is pointing towards ground, it's pointing towards positive. And that's actually what we got the other way around. So here is ground, and that's what we got from here. Ground towards reference. Looks correct. It is basically, it's correct. This is, but it's also the same problem, probably the same problem that we had with this protection diode here. This was we had to remove it, otherwise the enable wouldn't work. So maybe it's a good point to add a transistor. Sorry, pin 1 was the cathode, but technically connected to the supply resistor because Zener. What? Yeah, it's okay. I think it's similar to the problem that we got before. This was the Schottky diode, or what protection diode, and basically the PoE wouldn't start up because of the auxiliary. Where is it? USB-C. This is the auxiliary pin. Would be like always activated. It's the same problem. We have like a connection here. There is like a a shunt regulator. Okay, anode and cathode. Anode is plus and cathode is minus. Yeah, it's like a Zener, but then I'm wondering if 3.3 supply of that diode is high enough to give a drop for the... Yeah, it looks right. It looks right, but it was basically the same thing as we had before. And we can fix it. Let me check. Where is... Yeah, look at this. This was also V-bus and ground, and this one prevented us. That prevented us from getting PoE. Yeah, D7 is Schottky, the other is Zener. No, this is also... Isn't that also a Schottky sign? No, wait. This is a Zener. No, this is also a Schottky. That's basically... Or is it a Zener? Look at the sign here. Looks like an S. Yes, I should try the PNP transistor. Okay, friends, we have... This is a VREF shunt. Okay, MTL. I don't know what this means. I'm a coder. I'm an imposter. I have no idea what this means. What a shunt means. What does shunt mean? I don't even know what pink is. And I use the snipping tool to get things from the datasheet and rotate them to check if it's the right way around. I'm a total imposter. Shunt regulator is the exact circuit you have for the 4040. Very common old people regulator. Old people regulator. Messwiderstand. Yeah, but it's the same. It's the same. But it's shunt regulator with a Zener, and the Zener is hooked backwards. Yes. That's awesome, but we got a problem here. I tell you, it doesn't start up because we have the auxiliary pin, like because of this shunt. No, but if it's high enough to get the expected rev voltage. Electron ash, we can test it afterwards if it's working. Or we can test it with the USB power. No problems there. We will test it with the USB power if there is like 3 volts spot on. I can test this. Oh, yeah, we have it. We have it connected. I will turn on the camera. It should work with USB, no problems whatsoever. Because we got like... So this... Oh. Zoomity zoom zoom. Oops. Moving all the cameras around. Okay, and let's basically test it here. This should be... Oh, yeah, let's connect it to USB first. I should grab a breadboard so it doesn't move around all the time. Oh, it's the first time it's plugged to a breadboard. Woohoo! It's so beautiful. This is beautiful. Bloop. Ha! Isn't that cool? Oh, it's a beauty. Look at this. Okay, there is only one row on each side spare, but let's check it. Let's check it if we get the right voltage here. Zero volts. Wait, what? Oh yeah, it's not connected. I need instructions in the chat like this. Your board only works with power. That's electricity. That's moving electrons. Electron ash. I need this from you. Look at this. Here, it's high enough. We have our 3 volts. Yeah. Okay, so this is actually working like that. But now we need more. There is more. Let me check if I can find it. I will turn off the screen capture because, oh, there is a microscope still. Because I have the other project open somewhere. The other project. My girlfriend was making fun of me because I always was saying, like, instead of project, I said project in all my videos. So the project, and now I'm always teasing her by saying project. So the new project. Okay, here I screen capture, share. This goes off. Hello, Jim. Oh, cool. Yes, that's this project that I was talking about. And here Christos added something from the reference circuit that is basically might help to fix the problem. So we just need a transistor. It's an NPN, is it right? And any NPN and this 43.2K. Do we have this already, or do I need to pick one up here? Yeah, that's an NPN. Any NPN. Okay. Let's get any NPN. I got plenty of any NPNs here. I have those NPNs and I have small NPNs. And now I must think of from dusk till dawn. We have thick NPNs, we have moist NPNs, we have what is this? bunch of... Oh, I found diodes. LEDs. Nice. I like LEDs. Okay. Pick your weapon. So, we have a breadboard circuit now that we can use to fix everything. Woohoo! Yeah! What? NPN has the arrow pointing away from the base thingy. PNP. it's a PNP. Okay. Okay. PNP. Da 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 da. PNP. So we got PNPs as well. I got everything here. I got also SMD PNPs, so we don't get like a super bad, where is it? No, not here. Oh wait, I have here this whole wall of here. I got, what about this shelf here? Shelf, focus, that says PNP, and inside we got MMBT2907A. Is this any good? No? 60 volts. It even says the pins on there. It's like very crude, but base collector emitter. Oh, sorry. This is the circuit. Whee! LBC, we have the M, I will check for the maybe we got it even here somewhere. Ivory MMBT 2907A. Loading. Yeah. Yeah, that's what we are looking for. I will just I will put it there. Now we can access the data sheet. Whee! Okay, let's check if this is right. Base emitter collector. Yeah. Okay. Let's check here. So this is base. This is what is the emitter and what is the collector? It's the 555 of the transistor world. Like that. Okay, yes. Okay, great. So let's do. I'm not very familiar. Emitter is the arrow. Okay, yes. It's oh. So it's not like MOSFETs, it's the other way around. It's always confusing. Base is on the flat bit. Yeah, that's base. I know. This is the emitter. This is the base and this is the collector. This one collects. Yeah, MOSFET is like they acknowledged when inventing MOSFETs, they acknowledged that energy is actually flowing from the negative to the positive and not the other way around. So electrons are negatively charged. And in transistors, it's still the other way around. So emitter is positive, but it's not emitting, it's collecting. So that's why they thought maybe to use completely different terms. Conventional current flow, TM. Yeah. Yeah, that's how you lose people's attention. If you basically make up stuff all the time to fix your, like, you still want to your, like, legacy stuff to work, like legacy code. Let me get some bread. I will be back in a second. Okay, got some more bread. Fruchtzwerg for the. Okay, Fruchtzwerg, we need to give you an update because you will basically say what I said already. We got the old circuit. We don't need this camera here. Where's the old one? Is this the old one? No, this is the new one. This is the old one. Okay. So today we added the voltage reference. You are in time for a coffee break. Yeah, today we added the voltage reference. Look at this symbol here. And now that we added the voltage reference, the power over Ethernet would stop working again. And that basically reminded me of one thing that prevented us from having power over Ethernet before, that we removed. My pattern recognition, since I'm like not an electrician or electric engineer, my pattern recognition says to me this pattern is quite similar to this pattern here, and we removed this pattern from our circuit before and it started working, and now we got this pattern here which prevents it from working, and when I remove it, it works again. It looks quite similar. Same issue as with the USB protection diodes. Yeah, but this is like a shunt. I learned it's called a shunt, whatever. And this is for our voltage reference for the ADC. Shunt regulator. Yeah. It's a different voltage rail. I don't know. Yeah, you are right. This is on 3.3 volts. Oh. Do you think it's a different issue? Like maybe 300 ohms might be like a little bit low? But I would say, have said, remove it again. Well done. It's supposed to break at 3 volts, and thus a voltage reference. Okay. Oh, okay. That the other stuff won't fix it then. So because Christos updated the circuit here, that could basically, this is from the reference design as optional. It's like a PNP transistor in between the auxiliary sensing and our USB-C rail. And what Christos thinks is that this would fix the diode issue with that we had before. So basically, here's, I think, this D2. Yes, was it D2? No, D7. D7 isn't there. But we thought, okay, let's try adding just this part here, this transistor part. I'm getting 3 volts only on USB, but the power over Ethernet stuff doesn't work. Well, we can try again. I will just plug it in for you. You are my witness. Witness me now. Now it works. It's random. It's some... Okay, Ash made the suggestion it might be some evil capacitive IPA that prevented it from... Great, it's working. Everything working now. Could be a power startup sequence issue. Yeah. Aww. I give up. Okay. I will update. We need to add to the manual. Power over Ethernet only works if a roter Fruchtzwerg is in the room. Maybe we will ship one small roter Fruchtzwerg with the board. So everyone, if something doesn't work, you just pull out the roter Fruchtzwerg. Like it has cap charged to USB, then the adder wouldn't work again until cap has discharged. What? Bad Vasilis bad conduct RJ due to fondue. Actually that's probable, but it's not the case. It's working. Your brain hurts. I think there's only one way to find out. We just need to test it. We will basically add this PNP. I need to find out where is the new one. Wait a second, I can open it here as well. Need to find out if there is a way to intercept USB-C somewhere here. We need to cut a trace to test our new stuff. Fondue eating to project ratio 60:40. As you can draw max 50 milliamps, is the resistor big enough? Where? Which one? 4040? Okay, yes, I will show it. It's only 300 ohms, so that's why I'm worried as well. It might be just too much current. Maybe it's too high current draw here. Because then you get like a voltage division here. This is acting like a resistor which adjusts this to be 3 volts. So basically the current that we draw is a few milliamps. No, yeah, it should be. Can we calc this? So we have 3 divided by 3.3 equals and the current, wait, the current is 3 times 200 milliamps? No. 1 milliamp? I don't know what I calculated there. The cheese is clogging up my brain. 1 milliamp, that's not much, okay. Yeah, it's across 300 millivolts. Yeah, oh yeah, you're right, 300 millivolts, yeah. So it's 1 milliamp, that's true. That's way easier to calculate, I'm stupid. I'm your favorite imposter on the internets. Internets. A new meme, the internets. I need to write it down. The internets. Not blowing up anything, yeah. Okay, this was a different issue then. I don't know what the issue was. But yeah. Should we check if we can add the other circuit then? This PNP and maybe the protection diode. Then we would have like tested everything. No, not tested everything, but the circuit would be complete then. Blame the IPA. Yeah, I might want to exchange it because it's quite dirty already. Maybe it's full of small solder blobs. Yeah, it's fondue today. That's the fondue phone. It's funded by my precious viewers on this stream here. This was the first of 6 batches of fondue that I received yesterday. So at least one good news here. You're drawing 11 milliamps. Uh-oh. Circuit simulator. I think the only circuit simulator that I tried was Reality. I think in the university I had like Spice. What's P-Spice? No. It has a Zener example circuit on it. Ooh. Ah. Let's crank it up to 11. Okay, let's try the PNP. Yes, we will do. We need to find a spot to cut YouTube. We need to find a spot to cut the trace for the circuit though. So we got this here, and we need to cut the connection to USB-C, which is, whoops, this is the wrong one, which is here somewhere. Where is USB-C? Is this USB-C? No. Which one is USB-C here? Power, ground. No, this isn't the right one. Why doesn't it say ground, high ground? No, we will continue guessing. This is the way. Yes. Okay, fondue is over for today. We got 60% more attention for the actual project. How to set the Zener voltage? Now what we want is not the high ground, we want this USB-C here. Which is the auxiliary. It doesn't say pin 7, okay, pin 7. This is the pin 7. Wait. Oh yeah, that's the new circuit. Aye. I'm in the wrong spot. Sorry. This was the version 2 already. We need to go to the top layer. Remove this. Yeah, and this is what we got before. Okay, maybe we can intercept it here. Because we need ground. Oh, is this a different layer? Is this the bot? No, we need the top. Oh. Let me check where we get here. Oh, it's connected here. Which layer is this? Inner layer. Oh, that's hard. We need to take this off first. Christos. This is hard to fix right now. That's an inner layer. I could basically cut it here. That's the top layer here. Yeah, I would rather cut it here, because then I can put on the extra component like in this area, and I have access to ground maybe. Here is ground. So I have everything in place. Drill it. Yeah, the 4040 was 3 volts. We measured it already with USB. No problems. Oh, we can measure it with the RPoE, the PvP power over Ethernet. If you're interested, let's do it as well. So man, this is getting hot, and I still didn't find my thermometer. Switch it so it won't show a negative voltage here. .02. I don't know if you can see it. Oops. Probably destroyed something here. So the reference is working now. Yeah, we can use enhance. Woo! We can use this space here to, yeah, like here, to cut off the trace and put like the PNP just in that spot here. There is still some space left. So under the microscope, what is hot? The coil? It was like the whole power circuit. Even the connector is warm to the touch now. That's quite some power. Bitman. PoE Fonzie. Yes. Let's dissect the circuit. I think even if this doesn't work or anything, it's so much fun to solder around and rework under the microscope. The microscope was quite a good buy, I must admit. Look at this. Look at this, how I cut this trace here away. Whoops. This is only the mask. Oh. I need to make it sharper. Oh, that's quite some copper I got there. And I don't even need to take off the power over Ethernet stuff. Okay. I will just enhance, sharpen, and enhance. It's blown out a little bit, isn't it? Wow, this is like so 3D for me. You wouldn't believe if you... It's like... I love this the most. This stereoscopic vision through the microscope. This is basically the best part. I can see like the depth so well. It's really enhanced. And I think I might have burst through all the layers of this board already. That's a Q-tip. There's some... Yeah, this is looking like... Okay, I hope I didn't break a layer below that. Let me check. Just carving up PCBs. No, it looks good. Okay. So we have USB-C, we have ground, we need a resistor. Bitman. Now it's still connected. What? No. Where? Should I test? I test the continuity because it's not connected anymore. Oh, I can turn off the fondue. Big man. There is a trace? What? Where? What are you talking about? No. Okay, let me show it to you. Here. This is the trace. Or did I... Oh. Okay. Okay, gotcha. Bottom layer missing here. Fuck. Sorry, demonetized. Man, and this is... Oh no. This is like the worst place to cut it. I didn't see it. Yeah, but then this ground is like useless. USB-C. It's like useless because it's only connected over the PNP then. I would need to cut this trace here. Should we dig up this trace here? Let's dig for this trace and connect this one again. No? No digging? Why not? What's wrong? Evil digging. Dremel. I will use the mini mill. That's like taking off, like we can precisely take off this like top 10 scariest repairs. I will take it. I will use it. Come on. I'm never the one who would like not take a challenge. No, I don't want to cut it below because then we have like this here not connected anymore. This will be like super evil. Let me dig for this trace here. I will find it. There's nothing else. Is there like... Oh, I don't see the planes. Oh, there are like ground planes all over the place, aren't there? Oh, let me... Solid. Solid. So, huh? Why don't I see them? Why are the planes invisible? Digging is sexier. I will dig. 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 I need Shift B. Okay, let's check. Oh no, I don't see any copper. I don't dig it, but I do. Come on guys, we can basically cut it here and access it easily. .3D view with huge layer spacing may also help. Just resolder it. It's my board! When I say dig it, let's dig it. Come on guys, you want to see me fail. Let's do it. I just want to see how it looks. I never saw... Oh wait, we have like... There is already like a ground layer here. Oh. Okay, digging might not be a great option. We have too many ground planes here. Let me show that. Like there is already like a huge copper. We would have like to remove a huge copper layer here. Here's like a huge copper layer. If we dig inside of it. Wait, here is the thick one. This is like... Let me check. Let me be a neurosurgeon for a day. I want to see how difficult it is to make it happen. We can basically, from this ground plane, we can basically make pads and connect it directly, and this will be super cool. And it's gold plated. We are gold diggers here. So this is the silk layer. Look how cute it is. Now let's cut the ground plane. Oh, that's quite some thick. let's pull it off from this side. Why is it so thick? Or does it only look so thick on this microscope? I need a sharper blade here. In a lower layer. What? Oh. Okay, that's it. Okay, that's it. I thought it would maybe less. I'm not good at thinking. I let you do the thinking then. But it would be cool to dig the layers. Let's clean it up. How about this move here? What do you say? That's a big brain move, isn't it? Why not thinking still three-dimensionally? I am Picard that beats Kirk who beats Spock in 3D chess. Or how was it? Who beats who? Or was it? I think it was Picard, not Picard. It was Spock who beat Kirk who beats Spock in 3D chess. So this is disconnected now, and we have both accessible from here. USB-C and the auxiliary. And the only thing that we want to do is to connect this one again. Okay. brain from the after no COVID masks, bitluni European meetup when? I don't know when I'm vaccinated, fully vaccinated, and I'm up to it. I'm not sure where and when. I would say Berlin at some occasion, or I don't think that like make okay, this is it's still working. Now we need to add the PNP. What is this? Not MakerCast. Maker Fair. I don't think that Maker Fair will happen this year, but that would be a nice thing. You're in Canada, Jay. Okay. Jay, how is it that you have a Polish name? Like Jay is not Polish, but Rogozinski. So with aux lifted, PoE should always work fine and be dominant power supply. Yes. Oh yeah, we can try the dominance of it. Let's try it on like here. That's also something that we can test. Whee! It should be always like super bright. Super bright sounds like a chick flick. Okay, dim. Now PoE. Yes, dominant. Still dominant. This will work better still. UK, oh no, wait, it's not Europe anymore. Actually, UK is still Europe, but not EU. What? What? Stream okay? Did I kill the stream somehow? It says connection is good. You are just messing. Okay. Made you look. Okay. Let's test. No, let's not test this. This is the wrong one. I need the other one. Sorry, will share it in a second with you. No, this is also not the right one. Where is the right one? I have like 5 easy EDAs open at the moment. This is the right one. Okay, I will share it in here. Okay. Which version? This is version 2. Here. Okay, so this is mine. So this resistor here, does it need to be exactly? Yep, Polish and other stuff. When I lived in Poland, we had a neighbor who had the same name, Rogozinski. That's why I was surprised seeing your name. Yeah, it's a melting pot, like the US. But somehow, I don't want to be political, but somehow in Canada, either it's not like it's reported or anything that well, but it seems to work out better than in the US. This cultural melting pot. Yeah, especially I love Canada. Canada was one of the countries that I would like migrate to. I thought to buy like a small island in Nova Scotia or something when I was like mid-20s. Because the islands in Nova Scotia, like a small island, it doesn't cost much. It's like 50,000 euros or something. And Canada was really tempting. I love nature and such. Polish, German, French. Yeah. Especially, how can you be like, even if you got like two main languages in a country like French and English, it's not possible to say one is like more Canadian than the other. Yeah. But it's like Germany is basically the same. Especially where I grew up in Frankfurt, it's like a huge melting pot. Okay, let's continue with that one. So we got everything covered. But I must admit, I would love to live in Canada. I think the people are so polite. At least that's what everyone thinks, that the people are polite. British Columbia is amazing. Okay. You love Vancouver. Oh yeah. Either Canada or New Zealand. But New Zealand has the problem that it's so far away that if there is like something happens, you don't see your family anymore, and if something happens, there is not just hopping on a flight and getting to Europe, because it takes a complete day at least to get back to Europe. So that's I thought I have been to New Zealand before, and it's so beautiful there. It's basically, it remembered me of Scotland. I was in Scotland. It was quite similar to some places in New Zealand, and it is basically everything. New Zealand is like really cool. What I didn't like is that the water, like the tap water, is chlorinated. We don't have this in Germany. You can basically drink tap water. It's not chlorinated, or not to that extent that you would taste it, just in like rare cases maybe. But yeah, that was something like I had the impression that in New Zealand that Coca-Cola company owns all the water production there. Because I wanted to buy a simple bottle of water in the supermarket, and basic water was like $1.50, unless you buy a jug of water of like 5 liters or something. If you want to buy like a bottle of water, bottled water, it's like at least $1, even more. I was like surprised, and everything, every water was like from the Coca-Cola company or all these. It was like very sold out. The water market is sold out in New Zealand. At least that I got that impression. Cheap water filter. Yeah, that's the last thing that keeps me from moving away from Germany. When they sell the water, like tap water, to like business, like they did with the telecom, and like they did with the public transport, I will move away as soon as they sell it, and it will basically destroy everything, the quality, the living quality, even more. I drink tap water all day. Where do you live, Andy? Bad Coca-Cola company. Pepsi is the way to go. Mm. Ah, so refreshing. Canada tap water is pretty solid everywhere. Yes! Double speak for zero health. Yeah, that's great. Tap water, like drinkable tap water, is like one problem less that you got. Free healthcare, like free water, free healthcare, free education, maybe free internet as well. Other basic needs should be covered. So you can concentrate on creating this board already. Yeah, it's not aspartame. So I think it's not. Oh, it's aspartame. Ah, it's a conspiracy. Okay, okay. Do we want to figure out how this works here? So we have the base. I already forgot what. No, this was. Where is our? No, this is the wrong one. Ching chong chi cha. This one here. Okay, this is the base. Base emitter collector. You people like to be political today. Global president. If you think about it, basically that's what I'm trying to do with YouTube. I hope that to some extent my channel is a little bit educational, and it's like freely accessible. If you get even free internet at McDonald's, in the parking lot of McDonald's, and you can watch YouTube there. And you can learn how to connect an LED like a different way. So let's work on free education for everyone. Lifelong learning and free education. So we have the base here, the emitter, which is plus, and the collector, which is. So we need to connect this leg here. So you said this is the collector part. This goes to aux. Ah, this is the emitter. Emitter, collector. Open MIT courses? I didn't. Me neither. I thought the global president was the guy from Spaceballs. We get like the Idiocracy. The movie was so hilarious when it came out. And it was so often referenced in the past 5 years. We had the president there who watered like the crops with Gatorade. When I turn on the TV, most of the channels just show, or some of the channels just show like top 100 hilarious moments, or all the time. It's like this ball kicking stuff on Idiocracy. Basically, it's the same. Okay, I admit that I still watch like a little bit of trash TV and like this true crime stories, like medical detectives in the night, where I'm like passing out. I watch medical detectives, but that's memes for old people. Oh no! Okay, base. Emitter, collector. So you said emitter is the one with the arrow. The plus side is the emitter. This is the emitter. I need to concentrate now. Okay. Emitter, collector. Collector is 3. Okay, so let's do it. Field programmable, okay. That's a bank. Certified old person. Yeah, people, next week on Tuesday, I'm 42. It's a good answer, but I don't know if it's a good age. It's the age where I need to go to the doctor, so he tests my prostate, like get a prostate exam already. Oh, 39. Hey, Sion. We had everything on the stream today. Even talking about prostate exams right now. Tap water prostate exam. Oh, you people. Ah, so cool. Okay, let's do this here. I will switch to the microscope. Woo! Yeah, I even tried to cut through 3 layers of board to bodge it, but now we just lifted a leg and that's basically the same thing. I might want to lift it even more, but I'm afraid I will break it off. Okay. So what we want to try now is a bodge. Whoops. Oh, that's like, maybe we put it over here. So we basically not, yeah, I think I will put it over here. Or we put it on top. We can stack it like this. This will be like the rider. Okay, let's do it like that. Whee! Oh, I really don't want to use the super thin one. Will this work today? What do you think? No, it's quite hefty. I think we need the thin one again. The super thin bodge here. Wait, is there something between the auxiliary and the collector? I need to check. Need to check if there is something between the auxiliary. Yes, there is a resistor. Oh no, there is like a... What is this resistor here? 12.1K. Oh, we need a resistor. Okay. Let me get the 12.1K. This will be like super strange thing. Or should we just put it on the breadboard? But I just want to stack it to be like 12.1K. Found that one. And this goes to the auxiliary, which is there. Oh, we don't even need a wire then. Yeah, this one here, between auxiliary and collector. Okay. Look at this. So, what we got is like this and like this. And then we just need to solder this O4 or 2 component in between. This is our plan. Cool, that worked. Oops! Where is it? Here. Ah. I take the different tweezers now. It's a little bit too hard to work at confined space. Let me get some. Solder it first and then fix the positioning later. This is alright, yes. Okay, cool. Isn't that a beauty? It's like a beauty of a botch. There is a resistor in between and the leg is just bent up. Nice. And I hope I got the pins right. So, next one. Ha! Light activated glue. Yeah, I need to get like some of these. Flux, please. Yeah, a proper amount of flux. Okay, what's next? The base. The base is, let me check. Base is this one. The base is on the right side. And the base needs to go with like 43.2K, which is basically one of the higher resistor that we already got here. At least I think so. Christos, can it be like any of the resistors? Like any... I have 49. Okay. Yeah, but on the base as well? I have here the 49. Oh no. No, that's the 49 ohms. Ah, that's the wrong one. I need something. Here's a 10K already. $100K here. I have no clue. Okay, I have no clue because I really don't know. Okay, I just take the 10K because it's a quite common one. I take 10K there on the base. It's basically just current limiting, that's all. Oh, I also need to know where the ground is. If we got ground here. So here how do I do it? Okay. Oh no. Okay. Now let's find. Can you even see it? It's like black on black. It's basically just on the cliff, like on the ledge there. A little bit tilted, but it's there. Now I need to find the ground there. Why is it connected to ground though? Okay. I have no clue how this works. Where is ground on my board? Where is ground on my board? Give me ground, give me ground. We have ground here, the fourth pin here. Okay. Sion was here for 5 seconds. Yeah. This is ground. Okay. Zoom out and try to. So it's funny how the magnification is a little bit different for this one here. Okay, so let's do it. I hope that I don't desolder the other side again. You have to be very careful here. Or do I stack it upwards? I could like tombstone it. Yeah, this is also right. Ah no, fine. It's fine. I don't see it as like out of focus, totally out of focus right now. Is it? Oh, this is like, what's happening there? I need a clean soldering iron here. You know what? I just put it down there. I hope it's still working. It looks really wasted. Can you even see that? Yes. Still. Can you even see this thin magnet wire? I need to zoom back and forth to see if it's actually connected properly. This is something I learned from Louis Rossmann. I wouldn't think that this works, but at this scale, it's really like, yeah, I think this is alright. Yeah, it was alright before I disconnected it again. I just need to make sure that I need more flux there. That the protective coat is gone, and this is only when I put some flux there and keep it my oh yes, that's what I'm talking about. Nice. Okay, for comparison, I will just show you a hair for comparison of the thickness of this wire there. I don't think we need much current. I can't even, my hair is so thick. I can't. Oh, here is one. Where is it? My hairbrush here. Take one. So, for size comparison, this is my hair. And this is the wire. It's basically 50 microns. Let me zoom in more and give more light. So this is our bodge wire, and this is my hair. So it's basically this, my hair looks even thicker. I think it's the same. Unbelievable. I never thought I would use wires that are so thin and solder them by hand. That's basically 50 microns. Crazy. I don't know if you missed the last part. The last part where I just zoom out. So you have a comparison. I took the speaker, pulled off the membrane, took this coil here, and I'm basically, let me zoom out, if I can. Can I zoom? And I'm using this magnet wire from this coil here. You can see my fingerprints. This is crazy. Here it is. Yeah, if I would have hair, there is no hair on my hand. Like, I don't have hair on my fingers for comparison, but it's quite thin. But it does the job. Okay, next one. Yes, the enamel coating just goes off with the heat. But I set my it's way easier with this thin wire. It basically goes off, and it goes much more easier with flux. And I also set my soldering iron to 340 degrees C, so it's quite hot. Usually you would need 400 degrees to get this coating off with basic solder, but in this case it seems to work fine. I wouldn't think so, but I saw Louis Rossmann doing it and it basically works. As we saw before, because we already did this to our pins of the Ethernet. Yes, that's the goal. Make the USB dominant again without sacrificing diode protection or a protection diode. Okay, last connection is basically USB-C. That's the last pin. Okay, only one pin to go and we are done. We can assume that this thin wire is also acts like a fuse. Oh, there is like dust. Okay. This huge capacitor is making my life miserable here. Okay, there is still this protective coat. You can see the protection is gone now. It's covered with solder, so it burned off. And now it's submerged. Okay. And last thing to do is to attach it to the pad, and we are done. Woo-hoo. It's a little bit blown out, but I can't change it easily. I would need like a knob to have it not blown out. Okay, and this is also attached. And done. Oh, I feel like Louis Rossmann. Nice. Okay, this is it. We have two resistors, one transistor on top of everything here, like a small backpack. You can see it well. It looks funny. Let's see if we get magic smoke. We can turn off fondue cam already. There's no fondue going on anymore. Weep. Ta-da! Do you want to see it in full color, full goodness? So this is basically it. There are some hair. There's like a hair here, two hairs that are connected to this small backpack of this IC. And let's smoke time. Got integrated MOSFET. Yeah, it's like a PNP transistor, not a FET. But I would say let's try and release the magic smoke, shall we? I will zoom in a little bit. Ah! Here you go. We also don't need a microscope, okay. Okay, this is working. Okay. Shall we? Okay, let's try Ethernet. A waste of time. We should see smoke quite soon because there is like still some flux, and with PoE it's getting quite hot here, so there should be some a little bit. Okay, let's plug in USB-C. Air cooled. It's delayed though. No unplug Ethernet. I don't know, the delay was... Maybe we should make it really like, make it PoE dominant. Yes, the PoE has a delay. USB is prioritized right now, but I don't know if this is a good thing, because USB, we get instant USB power, but not instant power over Ethernet. So if there is an outage on one of those, then it would be better. So it's dominant on PoE, not on USB-C. Jumper to select priority. It could be a good thing, yeah. We could add a jumper to cut it if we want to, or remove, yeah, basically like a solder jumper. Christos, we can just add the solder jumper between before the aux. PoE take priority. I'm not sure. USB provides more current, so you would be never able to utilize it fully if you don't use the, like, if you had PoE connected. Yeah, and heat is, it's more like it's a hassle to convert from the 60 volts down to 3.3 volts, and it gets quite hot compared to only USB. So it's a good thing that USB is dominant right now, but we should add a jumper that you can basically cut and solder to fix it again, a solder jumper to make it PoE dominant if you want to. I think that's a good idea. To make PoE dominant, the D2 is wired differently. Why? A dual jumpers. Is the power dissipation of the buck regulator okay? Yeah, that's something that we still want to test. There's two things on our plate still, and we are already past 4 hours. Okay, Christos, we can talk about this. Yeah. Let's call the whole thing off. There should be an easy option to make it PoE dominant. But we had it PoE dominant when the pin wasn't connected. So basically, it was PoE dominant. We used it like that. Yeah. Yeah, that's what I mean. We had it PoE dominant. Basically, with this pin not connected, the aux pin was floating. So if we put between the aux pin and the resistor, if we put like a solder bridge that you need to cut to make it PoE dominant, it's basically it. Different wiring of D2. Okay, let's check. Let's check. Let's check the different wiring. Page 9 and 10. This is okay, and this is auxiliary. So we got the diode. And this is connected to auxiliary. Low, this is okay. And aux. So we have the diode before it and after it. That's basically the difference here. But this is only aux sensing. The aux isn't protected at all here. Or what? TVS. What's TVS? We have everything on the circuit. Oh, the TVS, the protection diode. Okay, yes, I will check. Let's get it on. Otherwise, it doesn't make sense to have it. D7, yes. Let's do it. Protection diode. Where is it? This teeny tiny mini diode. It's so small I will never find it again. Oh, here's my phone. ESD, is it the ESD, what is it, 10 amps, 6 volts, wait a second, I need to check if it's the one, is it that one, D2, no, D7, where's the old one? Here, D7 and ESDN 5 volts. Okay, this is the one. Yes, yes, I will solder it on. Let's get back. Let's get back. We can solder, yes, we can solder it back on. This here, woohoo, last component left. After all this hassle, we got here some components. Okay, oh yeah, that's like that's nothing that we can solder by hand though. This one is so tiny. Woo! Lip. Oh, which way around? This way around, huh? Okay. There's no airflow whatsoever here. Okay. Moment of truth. Did it fix it? Any bets? Do we get any bets? Thumbs up or thumbs down? Or yes or no? Whatever you like. Does it work or not? Boom! Aaron! Two thumbs sideways. Sion, you are always so skeptical. What's this noise? Do I have like a crash? Hearing crash? Will be fine. Work? Thumbs up? So we have mixed opinions here. Okay, let's see. Blip! It tries. It Sion, you were right. It works sideways. How's this techno track? Ah, it turned on. Please help. Okay. Oh no, it's cold start. Yikes. Beep 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 beep. Morse code for SOS. Now it works. Really? Now when the capacitors are all charged up? Or was it just overheating here? Maybe it was overheating somehow. Grab my scope. Oh man, this is like... No! I hate it! Really? Wobble connector? No, there is no wobble connector. The connector is good. This is like a quality connector for €4 or something. Man, I hate it. It's like some capacitors are charged up or something. It's haunted. Kill it with fire. Short the caps and retry. Okay, I should short high side, low side. Okay, let's discharge. Oh, this is like... But do I get to the high side, low side things here? Where is the high side, low side? I need to turn this, I take it off and I use the huge capacitor first. Like here, this one. Basically that. Maybe use tweezers here. To just discharge these two, this side, and this side. Is it connected though? I don't know. Let's try again. Oh wait. Oh, never rework on your breadboard. Oh no. Oh no. Look, This is exactly where this hole is. Oh no! Yeah, I was reflowing here this diode, and here is a hole. I basically toasted the board. Oh no! I have one like that too. Yeah, that's not my first one though. Okay, let's test. What was it? Maybe it was still too hot or something, the diode. I can imagine it was still over 100 degrees C.
Dazu habe ich Folgendes gefunden.
No, Google. Okay, let's try USB. I am going crazy here. Sounds probably Fruchtwerk. What? There was a short red one. Okay, the first attempt, it was like a super short red. Boop, red and blue. Okay. Diodes can be at least 150 C. Yeah, but it was more than that probably. I had the rework station at 330, and I was reworking here, and we have so many ground like planes, and everything was 300. So it takes a while to cool down. You saw even we melted the breadboard there. So probably there was an issue with the diode, like overheating. We could try, if you want to, we can try and heat it up and try again connecting it. Should we try to connect it after heating it up a little bit? To see if that was the issue? Do it. So we can confirm it, basically, my theory, if it works. So I will just heat it up with the hot air station and come over, and we can connect it quickly and see if we get the different behavior, or it basically was some evil IPA or something that I didn't use this time, but anyways. I will not turn the microscope on for you because I'm basically just heating up the board there. Okay, cable, and let's go. Doesn't do anything. Let me turn this off. Is it still hot? Oh, it tries. Do you see it? So my theory is confirmed. It's the same behavior. It starts to blink. Now I will cool it off. It's fixed like a man. That's all I say. It's heat switch, that's feature, right? Ship it. Yeah. Lesson learned. Yeah, I was right. And for once, the fondue really works. So this is good brain fondue. First, what? You missed the best part. Just scroll back. What we just can confirm is that if you give it a blow, it fixes things. So the diode was basically too hot from the rework, and I just reproduced the issue, and as soon as it was cooler again, it started to work properly. Story of my life. Yes. Ugh. Okay, Christos. So circuit confirmed working. Okay. You can even. I'm not sure if the PNP is basically similar to the one that I'm using. You have used a different one. I don't know if the pin configuration is the same, but you can basically proceed with the circuit. Oh no! One thing, we need to test the clock. So are you people tired already, or are you up for a short software fixing testing? Pin config is the same. Nice. Okay. That's like another session, I think. We are like already 5 hours in. You could scope it there. I could scope it with the output ground and so. 15 hours. But I think most of the people here need to go to bed right now. Push it through, it will succeed. Yeah, I think so. Why did PNP swap fix anything? Because we don't get like this current flow in the different direction, probably, or something. I don't know. It's like a reference design. So the PNP basically. Maybe Christos can explain it. It's like it's probably insulating the circuit. Is it? No, it isn't. You may want to drop the transistor in its spot. Which spot? Oh yeah, Fruchtzweig explains it. Leakage. Okay, yeah, so we prevent the leakage. Yay! Okay. So there is one elephant in the room that needs to be addressed. If you are up to peoples, if you are up to doing some testing, not testing, we have one thing, one feature. Let me share the screen with you. One feature on the old board that's basically enables us to select the clock. So currently we get reference clock out. That's the 50 megahertz clock. Where is it? PoE, PoE. That's the flash. Oops, that's the connector. LAN IC. LAN clock here. So we have this enable disable. We have like this solder jumper that we can solder to disable the clock, the 50 megahertz, and then we can basically solder this here. Yeah, we can disable this one here. We can solder this here and use GPIO 21 to output 50 megahertz on this pin. Oh, so many elephants. Okay. This is so valuable information. You can learn so much stuff in the chat. Okay. RP2040 data sheet. And now clock outputs. So, clocks. Clocks, overview, sources, generators, frequency counters, clock generator. Clock output GPIO can be used to clock external devices or debug on chip clocks with logic analyzers or oscilloscope. So we can use this increase the LED resistors a bit, worth a shot. What? Ash? Thanks, Ash. Okay, Ash, I maybe missed what your suggestion is. What's with the LEDs? Okay, yeah, I know. I need to check if we need the jumper. Maybe we can basically use the same pin and don't need the jumper in the next revision. Ash was commenting on Rotor's comment. Oh, okay, yes. Okay, thanks. So Fruchtzwerg knows what this is about, so we might want to try it at some point. That would be like another resistor. But then when we drive it from USB, it will be very dim. Okay. Oh man, this is something you should tell us before, because now I would need to break everything up again. we just fixed it. It's not a real solution if you ask me. Yeah, it could work and it could not work if like the tolerance of the resistors are different or whatever. That's basically like maybe not a solid solution. It might work, but it's like okay. Let's try this here. Can we use this output here to output a clock? Okay, duty correlation. Okay, but we need a clean clock, don't we? A kluge idea. Frequency counter. Can we even get a clean clock at 50 megahertz? We have like our, what is our, we don't have like a divider or multiplier, a proper one. What's the internal clock? Oops. Oh, stop it. 12 megahertz. Oh yeah, that's what we need for USB. But we also, USB still working when we use the internal, like the external 50 megahertz as a source. Okay, you're still talking about that one. Okay, let's check programmer's model. Muxing. Clock configure. I think I might be too tired to code right now. SDK provides clock configure to configure a clock. Okay. You should be able to use PIO to build a clock, right? Yes. Yes. I don't want like, so what we got right now is we have this code here that's basically a proof of concept, I would say. We got this from it's from Sandeep from GitHub, and what he needs to do right now is to use the external clock source, we have like a 50 megahertz external clock source at pin 22 as an input. So the system clock changes to this 50 megahertz and reinitialize everything to work with this new clock source. USB is still working. However, it's working. It configures like, that's like clock configure G pin. Yeah. I need to check this one. And we don't want to use like an external clock. We want to use the internal clock or the other crystal or internal clock to use it as a source for the Ethernet. Yeah, I need to check. I need to check if it's only on this pin. I don't know where you got this information from. I trust you, but I want to see what options we have. And okay, so this is like clock management API. High-level interface to the clock functions. And clocks to on-chip external components. It takes input from a variety of clock sources, allowing the user to trade off performance against cost, board area and power consumption. From these sources, it uses multiple clock generators to provide the required clocks. This architecture allows user flexibility to start and stop clocks independently and to vary some clock frequencies whilst maintaining others at their optimum frequencies. Please refer to the datasheet for more details on the RP2040 clocks. That's where we are coming from. The clock source depends on which clock you are attempting to configure. This first table below shows main clock sources. We are not setting the reference clock or the system clock, or you're specifying one of those two. We'll be using an auxiliary clock source. Then you will need to use one of the entries from the subsequent tables. Okay. The auxiliary clock sources available for use in the configure function depend on which clock is being configured. The following table describes the available values that can be used. Clock GP out can be... Yes, okay. PON0, USB PLL, system clock. Yeah, Fruchtzwerg, but there is like, we can configure like for the PoE, we can configure something for it to work maybe. I just want to try, let's see. Here you have like, there is like clock division. PoE. That's like 10. I don't know why. smconfig set clock tx is also 10. We might be able, so what we got here is like out pins, rep target. We have a weight 0 pin 2, weight 0 pin 0, weight 0 pin 1. I don't know how this state machine work. Post killers, yada yada yada. So if users messes around with RPI clock, in any case it would break, right? Okay. So the idea is, the goal is to have the main clock remains the initial frequency and everything up to the user, completely flexible, and then use the configuration, the auxiliary clocks that are independent, to give out, like on the one pin, the 50 megahertz. Oh, you need the Ethernet to work. So maybe the state machine needs like the base frequency of the Raspberry Pi to be exact the initial frequency, whatever that is. Currently it's underclocked, and we want the full capability of the Raspberry, so we want to fix that issue, that it's running currently underclocked at 50 megahertz. We just want to add some dividers and so on, so the PIO stuff works. But the first step to do this is to get 50 megahertz at one GPIO output with the initial clock setting. So what we want to try now is, even though it might break the Ethernet in the first place, is leave the initial clock of the RP2040 like it is, like what's the initial 125 megahertz or something, and configure an auxiliary clock to 50 megahertz and test the pin on the oscilloscope, see that we get a clean 50 megahertz out that we can use for the Ethernet, and then fix the GPIO stuff to communicate with the Ethernet IC. At least we would have a synchronized clock. I think that might be a bigger coding problem than we see now, but use a PIO for the clock. Yeah, Jay, I would say that's a limitation basically. We can't like do everything. That's the same like we already used like the two state machines of the PIO stuff for the Ethernet communication that are also off limits to the user already, unless he doesn't want to have the Ethernet capabilities. That's also possible, that someone just wants to use the power over Ethernet stuff and do something else, not communicate or whatever. And that's completely possible. But if you want to use the Ethernet, two state machines are already like used, then you need like one auxiliary clock is then occupied as well, and you maybe not be able to change the main system clock as well for the GPIO state machines to work properly. We don't have to provide a clock, we have to provide communications that's in sync with the clock that is fixed by the Ethernet spec, I think. Okay, but what you have, like, we have the Ethernet IC currently has an extra crystal that we basically wouldn't need if we clock it from the Raspberry, if we have the possibility, because that's like the cost is another 50 cents or something, and those crystals aren't in sync. I don't know if the IC works that way. Currently, protocol does not use buffers in the Ethernet chip. All the data sent out by RP directly put out on the Ethernet wire. Yeah, and that's the problem maybe, because we have two different clocks that are off sync. Yeah, and we got like different problems with this case. Oh, there's again a like huge thing that's flying around my room right now. We have different problems. We just don't have the solution for a simpler circuit right now. We have like two different clock sources, and we use we turn off the crystal, the 12 megahertz crystal of the RP, to use the external clock, the 50 megahertz clock that is also clocking currently the LAN IC, to have a sync clock for the RP2040, and that's like also the limitation because we are clocking down the RP2040, and that's something that I don't think it can be justified unless it can't be avoided, but I'm not sure if it can be avoided right now. So I would rather try to use like the 12 megahertz clock to generate a 50 megahertz clock external like output on the pin 21 or whatever, and use it for the LAN IC to put it directly there. Yeah, Max, that's basically what we want to achieve. It's already bit banging for this 10 megabits or whatever it is. It would seem best to use a clock that cannot be affected by the user, right? Yes. So we have the possibility to use the auxiliary clocks, and I would assume that if you change the system clock, the auxiliary clocks would be like updated or whatever, because it's the same with the USB. When we clock down in the code right here in the main C, what happened last time is we use an external clock from pin 22, which is 50 megahertz, not the 12 megahertz. That's, you have a multiplicator for the USB, you need 48 megahertz. That's why we use like a 12 megahertz crystal, so we have a clean 48 megahertz output there, clock. If we like have the multiplier or whatever, however that works. Now we are using a 50 megahertz clock, and we are still able to generate like a USB connection or a USB frequency that's good enough to get the serial output, because we still have like on the USB 2 protocol we get like serial output that gives out all the output, and so USB still working, and that's basically what's happening here. It says initialize STDIO after the clock change. So basically this here covers all the clock changes from the system clock is updated, and all the clocks that need to be updated, like USB, and this one here basically updates the internal variables for delay, micros, and whatever it needs to do there. That's basically what I think it is. I'm not sure because I never coded RP2040 before. PIO have an NOP instruction. I think it could have. I don't know how this works. I never saw like this state machine before. I'm really confused by, even by that I'm confused right now. What does that mean? Wait 0 pin 2, wait 0 pin 0. Whatever that means, maybe another wait 0 pin 0 would mean like wait a clock cycle or whatever. Yeah, I have the same init code on my OS primitives, yes. Yeah, I would assume so. So maybe the only one who could help us right now is Sandeep. Maybe we should just reach out to him and ask him or check. Okay, let's do the obvious. Let's go to where is it? This is not. Let's go to GitHub and check. That's not it. Let me check if I can find. Maybe there is like a request or in question already there about the clock. So this is. So issues. Oh, open is issue. Whoops. No, pull requests. Action projects. Nothing. Labels. Nothing there, unfortunately. Maybe we should try to contact Sandeep. Ottawa, isn't that Canada? Okay, I will try to reach out to him. Maybe. I don't know why, how yet. There is. Oh, Twitter. He has Twitter. Yeah. I will tweet him right now. Let's do it. Is there no button to tweet him directly? Oh, here, yeah. Hello Sandeep, we are currently developing an RP2040 RPoE enabled microcontroller stumbled across your what's this the project name YouTube fame. No, I don't pull that card. Maybe. Yeah, I think whenever I get the first batch of boards, he would be the first one to receive one to basically, so he can play around with that and maybe figure out stuff or I don't know, continue his developments there. During live streams on YouTube. One question. What is the question though? One question though is, did you try to use an an internal aux clock instead? So okay, so what do you think should we ask? So please help me. I'm not oh, tell him what you're doing. Yeah, I told him we are currently developing during live streams on YouTube and stumbled across huge help already. One question though, did you try things instead? No. That's really like only if it as far as I know, it's not showing like very publicly if it starts with at whatever. I don't know. I don't want like to force someone to reply, but I can't write him directly because he's like he doesn't have. I will just tweet it right now and see what happens because I would like I can't send him right now directly. Open an issue on GitHub instead. Yes, I could right now. That would be a thing. So the DMA clock becomes relevant. Okay, let's. But how do I issue it? It's not an issue for me. It's like okay, I could maybe label it like an, but I don't want to be like a smart ass. I just want to get his reasons for the way he designed it right now. He has like 980 followers, so look, he's even like he has even the right followers here. Look, Ivan Grokotkov. This is like the one of the main devs of the ESP SDK. Luke Wren, and so on. He is followed by the gods of the embedded development. He also might have the new discussions tab on GitHub. Okay. Okay, the last time he tweeted was a little bit but he uses Twitter more often than I do. Okay. We can okay, let's basically read up, maybe he will answer it. Okay, maybe. Okay, yeah, I will do it afterwards. Or you can help me formulate questions. I'm not native speaker. So much on the plate. Let's try to get a clock, shall we? Where is our in the while pull the scope and let's play with the dividers. Yes, that's what I want to do. Yeah. Let's do it. We are only streaming six hours almost. That's like nothing for where's the here Raspberry Pi SDK. This is what can't type. Do it. Example. Interesting. I don't know if you can read this. There is like counters. So you can basically count. Whoops, sorry. I wanted to scale it and lost it. Whoops, where is it? What? Here. You can count the internal clocks. Peripheral. ADC, RTC, clock source. Clock sys. Maybe your system clock is also not in sync. My falling edge is stronger than my rising edge. IQ timer. Okay, clock configure. Ooh. Oh, you are. So this comment says SDIO init all initialize UART. So it basically sets all the dividers and initializes the serial communication. Measure frequencies and then print hello 48 megahertz. So it sets the clock peri clock frequency and the main clock configure G pin. Clock configure interesting. Okay, maybe we got this example already. Let's check if we got the examples. PIO UART watchdog. It should be there if it's in the SDK. Pico SDK multicore divider. Where is it? What's the name of this example? Or let's check. No, this is not the one. He's trying to reach $100. Really? Yeah, that's what I also try to reach. The problem is I support people, but it's like at the end, if like me and Sion and Brian and we are supporting each other all the time, the only who benefits at the end is like the man in the middle. I can sponsor him. Let's say, oh wow, he has powers of. He uses the power of 2 of like 2, 16, but there's no 4 and no 8. $16, that's substantial already for me at least. I use the power of my, let's see who we got. 10%. Let me sponsor him. I will sponsor him. Let's start with $2 a month because he is already such a help. What is this? Pay prorated? Huh? Total do now? Huh? What does it mean? What does it mean if I click that one here? Do I cover like the cost or what does it mean? Prorated. Anteilig. Hä? I don't get it. I will use the power of my influencers here, of my chat. There is one of what? Exactly. Yeah. Oh no, yeah, I don't want to like I don't mind if it's tomorrow like another €2 or dollars or whatever it is. It's at least I don't use like 1024. At least I think the board didn't decide on making it open source yet. I had some expenses that I want to cover with a little bit of income, but at the end I think I will make it like open source as well. Just maybe like Sion did it with releasing on when it's finished. 6 cents a day. You can start to sponsor him when you wake up. Oh wait, we have the 1st of July already, at least here. I don't know what. Yeah, let's not talk about it. Let's try to fix the clock right now. So we are looking for the we should find a clock somewhere there. Clocks, there it is. CD clocks. Hello 48 megahertz. Hello GP out. So we have plenty of examples here already. Just that external clock is 25 megahertz. So nothing works but the communication. Oh yeah, okay. It doesn't matter. I don't really care right now. Okay, so let's take a look in the examples then. Can we use like make fs data? Oh yeah, that's that. Pico examples. I will open this. Oh no, that's the wrong studio. Oh, ouch. That's the wrong code. Ow, 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 ow. Do I have open with code? Oh no, I don't have open with Visual Studio Code. Yeah, whatever, then use regular Visual Studio instead. Okay, so here we are in light mode. Your eyes are burning, probably. Should I use like dark mode? No. There's the dark mode. Umgebung. Or do I want blue mode? Okay, here you are. is... Okay, so we have the clocks here. GPI, hello GPI out. Let's take a look. Whoa! Really? Oh, see, it's 21, 23, 20. That's basically what we, that's all we need. Really? That's all we need? Okay, let's fix that. Okay, let's do it here. Oh no, wait. Let's not do it. Let's do it like this. We don't want to change it. We don't need. Okay, we leave it. We leave it like that. And we make 50 megahertz and 21. That's all we need. That's code done. We are finished. Let's build it. And done. Oh, that's the wrong one. There is an example that exactly do. Oh, that's the divider. I didn't read properly. What do you... Oh, wait. Interestingly, this one has a proper tooltip here. Oh, divider. Oh. For the future, we have like on our circuit, we have 21 as output pin. So we can set a jumper. There is a solder jumper on the board, so we can connect the LAN chip to 21. So basically, and that's the, we have currently the clock input at 22, but the output can be configured to 21. And we can, the tooltip says, if you can read this because it's quite small, it says we have 21, 23, 24, 25 are possible outputs for the clock. So what is this divider? So what is our main clock? Value clock, what's the system clock then? What is our system clock? I was just oh yeah, that is basically the input clock. So we use the external clock from the LAN chip that is connected to 22 currently, which is 50 megahertz. But we want here, this is like, then adjust the divider. But the divider is like, I will just check it. I will find the documentation. Where is my documentation for this? The data sheet. It's a bit messy. Yeah, that's 21. Okay, cool. Clock generator, source and divider. Okay. And what's the... What's the system clock right now? Or can we set it like... Yeah, that was the default in the example. But our system clock is like, it's... What is the system clock? Because it says auxiliary value clock sys. I will check. Ah, I can't check this. Raspberry. What? Oh yeah, control. System clock. USB clock, ADC clock, RTC clock, reference clock. Ah. Okay, let me check something else. What is... Pico SDK? What is that? Yeah, this is what... Let's run. I have like a ton of picos already here. Let's basically put an example on one of the spare picos, but I need to connect the micro USB first. Yeah, I was like. It's hard to find a USB cable currently. Here we go. That should be some micro USB cables there for me. I hope that is connected. Is it connected though? No, doesn't look like it is. Okay. Let's drop an example on that. Okay, we basically now we need the what is it, the PoE. Is it COM3? I have no. Oh no, it isn't. Ah. Wait, what? There is no. There is no. This example breaks the RP because it doesn't start. What? It doesn't show. Okay, that might be not a good example then. Let's try. Let's try this one then. We will see what we get. No, it doesn't show. Huh? Why isn't there a serial port? What? Are we still online? The chat doesn't work, it's broken. No. You guys are already sleeping. Ah, ping, okay. Of course. You're probably watching YouTube right now. Plop. Okay, okay. I don't get like anything on the USB though. Whatever I drop on this doesn't show on the USB anymore. I don't know why. Doesn't show as a serial thing. Ah. Let me check something. No. That's like an RP2040, like a Pico board. I didn't do anything to this one here yet. I think so. Let me try another one. Oh, this was. Maybe we stole something from the other one. No, doesn't look like that. Let me try. Huh? That one might be broken. I don't know why. Okay. So this one is showing, or at least it's not programmed yet. As soon I will change the clock or anything, it might break. Let me try hello. Hey. Why doesn't it show as a serial interface? Do I? Oh yeah, this one shows. Okay. Can we reset it? No, this. Oh, we had one with a reset button. I don't know if we can do it so quickly. No. I need something that directly reconnects. Okay. Let me change this. Main. What is the delay function? Let me do a delay so we have time to reconnect to the serial port. Sleep MS 5000, that worked before. Oh, that's the wrong example. Clock, hello. Let's do it here as well. No, not measure in it all. Okay, let's try this. Let's build. Maybe that was more than 5 seconds. $48 here. Do I really need to pull out the oscilloscope? Ay, 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 ay. Oscilloscopes are also noisy. Me no like oscilloscope. Oh wait, did I drop it on that one? That's no good. I might have programmed the wrong one. Huh? No. Oh, this one isn't showing as the U. Oh, wait a second. This is the wrong one. Okay. Let's see what we get at I will turn this on. Where is the... Oh. Lip. let's test what we got here. Oh, here are the labels. Ground and GPIO 21. This is not the right one. Okay, no. I want... Does this one set anything? No. We want this example on this one here. Okay. So we got like this example with the GPIOs on this Pico here, and we can now see if we get a clock on the oscilloscope on grounds and 21. Yeah, there is something. Okay, 1 volt per division. Where is this vertical display, horizontal there? And we got a frequency of, what is it? Doesn't show. Measurements. Measurement, statistics, acquire cursor, math display, add measurement, frequency no signal, oh frequency 2, we need source 1, peak to peak, frequency, oh I love touch, frequency, you done. Wait, what? No. Here. Okay, 4.668. 4.68. You can, I will show it. This is divided by 10. Ah, yeah. System clock is 48 megahertz. So what if we don't use... Oh, wait! Okay. We have different sources here. This different clock sources. So system clock is the same as USB clock. What kind of clock sources do we have? One potato. Get a battery one. It's getting cold, my feet are getting cold. What's the highest clock? PLL? No. Wait, is it always 48 megahertz? No. We have like serial output. Oh, that's the base clock speed? Really? We can't reach a higher clock? How do we get HDMI then? Let me check something. Clock dividers. I thought it was 133 megahertz. Okay. I'm wondering. The oh yeah, it says up to 133 megahertz. Okay. Okay, we need the least dominator between 48 and 50 megahertz. So we need a clock no, what I mean is we need 48 times 50 2.4 gigahertz Good night, Christos. Look like we are doing Wi-Fi on that. Yeah. Okay, let's check the clocks here. Oops, we don't need that anymore. 48. What is out of specs for 10 megabits per second? So we need a 50 megahertz clock. But is it within spec if we run it at 48 megahertz? Maybe. So the only option is this here. And yeah, that one. 48. $25. I don't think this is possible. We can't get a clean clock for that. I'm also getting tired. Clock configure. Configure specified clock. See the tables. The clock configure main clocks configure. Main clock source can be 0. The auxiliary clock source, which depends which clock being set, can be 0. Frequency of the input clock source, requested frequency. So basically what we want to do is, yeah, looks like I need that 50 megahertz crystal. I don't see a way around. We can basically, if we decide to use this external crystal, or if we decide to use the LAN, we need to switch to this external crystal, and then we can change the internal frequency maybe to a multiple of 50 megahertz, which can be like 150 megahertz or something, or 100 megahertz. Ridiculous. Okay. Interesting. Yeah. Try it. Yeah, we need that scope. Okay. So set sysclock 48 megahertz. Maybe we have enough tolerance in both, like USB and Ethernet, that we can meet in the middle with the frequency. Or maybe change divider and confirm you see change on the scope. Let me check. I need something for my probe. We can test a few things. Here. This here. And I need a few jumpers. Ethernet is pretty strict. Okay. What does pretty strict mean? Oh, I don't even see where my pins are. Where are my pins? Because I can't read the labels. There is GPIO 21. Where's the ground? There is a ground. Okay. I wonder how it's getting 50. Yeah, that's what I also wonder. Let me check something. We will use what's this or this? Why can't we simply set a different clock? Like, what is the reference clock though? Maybe we can try different clocks here. Is this the RC oscillator, crystal oscillator, PLL, clock source, oh no, clock source, clock sys. Why just not call set sys clock kilohertz true? What? Yeah, it's still live. Life is life. Da, 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 da. Let's check what we get from our clock source here. Let's make it. Let's not. Oh, it's not even connected. Wait. My USB isn't plugged in. Ooh. Okay, let's check what we get. Wrong direction? No. No edges, it says. Wait, what's this? Oh, I was on fine tune. Huh? We get 125 megahertz. 120. Okay, so let's divide it by 3. Is it an integer? Oh! I broke it. Let me check clock configure, change. Okay, so now I see. I'm trying to speak German. So basically, PLL USB is always 48 megahertz. So when we do clock configure, like here, clock configure, oh no, it doesn't show any. Clock configure, system clock. Let's do system clock, and then clock sys control source value clock source clock system auxiliary. I don't get what this parameter. And then as clock source we tried something different. Wait, here. Go to definition. Which clock source should we use for that? And basically set it to 50 megahertz. Okay. I need this documentation though. Value clock reference. Auxiliary source. This is clock index. Okay. This is not what I wanted. Come on. Clock configure. Second one? No. Where? Which tables? What? Oh, here. This is the main clocks. This is an RC oscillator clock source PH. What does it stand for? Then we have the crystal. This is RC oscillator or auxiliary. Supper time. Okay. See you, Ray. I need like a diagram or a description of these clock sources. I don't know this architecture of this of the IC. Is there like in the... This is not the date. I don't need the data sheet. I need the... Okay, here. Clock generator. Watchdog and timer reference clock. Okay, so here is a short description. Clocks is processes bus fabric memory mapped registers. Peripheral clock, UART and SPI. USB clock, ADC clock. And real-time clock. What does the real-time clock mean in this? RTC. Oh, that's for like seconds and time and so on. Okay. So the only option for us is, because we want the GPIOs also to work, the DMA to work with the same. We need to change the system clock to 50 megahertz, and we need a different source. The frequency of the clock source. Desired output frequency. Source frequency by frequency. There's a clock divider, okay. If switching a glitchless slice of switch away from aux first to avoid passing glitches when changing aux mux. Assume glitches source 0 is no faster than aux source. Oh wow, okay. PLLsys. Sys aux PLLsys. Okay. That's the 125 that we get currently. If I see it right. Yeah. Basically, when I have enough, I don't know if you can see it, but it says exactly 125 megahertz. So this is PLLsys. Let's use that. Oops. Aux. Yeah. Why doesn't that indent here? Okay. Okay, that's 50 megahertz. Let's try if we get the output that we want. Oh. Too few arguments. What did I miss? Wait, what? Oh, the input. The input first. Okay. There's no way we can get a 50 megahertz from 125. Yes. Alright, let's see what we get. Okay. Yeah, nice clock we get there. Yeah, that's what I would expect here. Okay. Let me just grab it. Yeah, we can basically, that's what we get. That's like 2.5 factor. So we need to set a different clock source. There's no way our Ethernet would accept something like that. Okay. This is the source. No. I need to check this again. So I'm like really stupid. This is the clock index source, auxiliary source, source frequency, and frequency. GPIO init, clock configure GP, okay, glitches enable. I need an overview. Oh, sorry. I need an overview of the clocks. If there is like an APLL clock, like on the ESP32, we might be even able to use that. But at this point, it's so complicated and like overutilizing all the niches of this thing that it might not be good to do it and just put on the second crystal there. Yeah, that's what we get. Oh, what is that? Duty cycle correction. That sounds like that might work. Yeah, that might work. But how do this? How do we do this? DCC. We need a clock of 150 megahertz. Okay. Pico dVi. Okay, there is in this in the timing state serializer now. He uses also a different clock. So what is... Let's take this as an example. Clock configure. Look also uses this. Oh. Set system clock from crystal, okay. DVDD. Oh, interesting. Let's see. Where is this from? I didn't see that. It's not like... Heh. That's a difference. That's Raspberry Pi Pico. Okay. Check. Set this clock. We are back at the function mentioned above. Where? Did I miss something? Oh, Fruchtzwerg! Where did you get this from? Why didn't see it? Didn't I see it before? Oh no! I'm wasting our time here. Or what? Oh, come on. Like this. We could run the example, see what we get. Yes, that's what we did already. Yeah, Fruchtzwerg, but where did you get this from? Where? Because why doesn't it, like the example or whatever, SDK not even mention it? I'm confused right now. I try to like work with what we get there. Oh, the overclocking article. Okay. Oh. Yeah, that's what I get. You just paste me this faulty code without a semicolon. It's all over the place. Yeah, but I didn't have time to read the whole article. I was just... Okay. That's the problem. You have an advantage here. I need to do 5 things at once. It's not an excuse. Okay, it's an attempt of an excuse here. Sorry that I didn't listen to you and wasted another half an hour. Sorry, I didn't follow. Aaron, really, I don't want like to involve your efforts too much here. It's not your duty to help me with anything. I'm really thankful if you do, but Oh, run. No! Why do we get 100 megahertz? I don't know. Oh, that's 100. Yes, that's 100. But we can do like 150 times. Okay, let's try. That's 100 megahertz. And then let's try 3. That's like close to it. A little bit overclocking. And let's divide it by 3. Or does it need to be like... No, it should be fine. Division by 3 should be fine though. That's what we saw in the example. That it's like... No, it doesn't work. Uh-oh. Did I break it? Let's try. What did I break? 100 megahertz doesn't work. The compilation time is so long. Nope. Oh, yeah. It's in kilohertz. Okay. Let's do it like that. I'm stupid. Sorry. Okay, if we can make it run, if we can make it run from the internal clock, we're absolutely fine. If we get the Ethernet at 10, we could even try 100 megahertz internet. Like, why wouldn't it work at 100 megahertz, 100 megabit? Should be possible. Now that we are able to overclock and underclock and side clock and okay, this clock isn't that clean. It's 50 megahertz, but it's like not a clean 50. Let's do it by 4 and clock it to 200. Yeah, more like it. Isn't that bad? That should pass. I would say that passes as clean 50 megahertz, doesn't it? What do you think? Yes, overclock that bad boy, send like 100 G heats. 1 gigabit feature. Megahertz, 100 megabit, yes. Okay, we got our clock, looks fine. We are running it at decent 200 megahertz right now. Okay. Oh, wait. Ah. Okay. If we want to run it at this clock speed, let's try 50 megahertz first. We change it to 50 and basically turn off the external 50 megahertz clock. Try to get it running again so it serves, like connects to the Ethernet. Test that and then adjust to 200 megahertz and try to set the GPIO dividers so we get like, oh yes it is. I just wanted to test your attention. Okay, this is... Oh really? Aaron, can I ask what you are doing for your living? Okay, 50 megahertz clock is fine. And let's do the changes here. We need to access the back of this. Yeah. Oh, wait a second. We can try to check if that should work. Maybe it serves the Ethernet already with the internal clock, even though these are not in sync. I don't know how that behaves, but you have 3 businesses with 60 staff to do all the real work? Oh, really? Oh, wow. Oh, that's neat. Fruchtzeug, oh. You just want to see the success and then be off. Okay, let me test if we get a connection or if what this thing is doing, because it should be alright though. If it doesn't need a sync, then we are not using the external clock for the RP anymore, but no. Okay, it doesn't work with the internal and external at once, so let's try the clock source. I will switch to the microscope because we need to check this here. Okay, wait. I need to check the clock first that it's actually... Where is the input here? Let me check. I need to see where we get our clock input from this oscillator here. Wait, what? 22 GPIO. No. Where is it? So we get reference clock. That's the jumper. It's 22. 10, 30. That should be that one. I have all layers on. Oh yeah, we should measure it here. I would like to measure the reference clock. Not the reference, yes, that the oscillator is actually still running, and then I will cut it. So basically I want to measure this pad here. So I'm sure we have the 50 MHz there. Then I will disable the clock with the small enable disable here with this jumper, and test again to be sure to not short anything there. So basically should be able to see something here, or just need to find where's the ground. The second here, this is ground. Okay, this is 50 MHz, and this one is also 50. Okay, great. So now I will do the solder jumper first. Okay. Now we can test it. Oops. Oh shit, I shorted it. Okay, the crystal is turned off. That works. Okay, There is no need to cut this trace though, but I will just jumper it here. So the reference clock is off and I basically need to get the solder bridge there, and that should be all. Where is it? Where is it for you? Okay, that's all. And then let's see what happens. Magic smoke or not? Rip. Let's see. I have no clue what's happening there. In like a few seconds. If we got it right, it should use the internal clock. No, 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 no. Oh, wait. This one is disconnected. It's why is this disconnected? Oh no. No wonder it wasn't able to connect before. Now I will never know if it will work or not with the desync clock. At least it works with... Oh shoot. That's like a horrible test. But, oops. Yeah. This is with the internal clock now. Yeah, we did ping it once, but I don't know when was the time that I pulled the cable. We tested it right at the beginning. Okay, doesn't matter. Okay, it might matter to know if a desync clock also works. It works with the internal. Didn't it work? Yeah, no. I don't know. Let me just get off. Okay, let me test it. Let me test it with two clocks. The internal clock and the separate external clock. I will take off the solder bridges again. So the external clock should work again. Okay. Now we have a external clock which is different to the internal clock, maybe off sync somehow. Now we can see if still working. No change there. It works with two clocks. Just set internal clock to something so low. I have no clue. Okay. What do we learn? We can use the internal clock, but should we? Should we try another thing? Okay, I will change it to the internal clock only again with the solder bridges. Like super quick fix here. Come on. Okay. Uh-oh. No, that's right. Okay. Anche. Okay. Okay, let's run it only on the, so we don't need the external 50 megahertz clock. We can basically run it also on the internal. Like, maybe we should just send a push request with this. Oh no. Yeah. No, but you have like a clean. I'm not sure. The device that he used was basically came with the clock. So why wouldn't he use it? Is the question. Okay, this is our internal clock, and we have connected it now to reference clock, and the reference, this clock is disabled here. So we don't need this. That's like three components. With this one is quite maybe expensive, and the internal clock. Now what we want to try, maybe last thing to try is today, can we use a different clock speed here? Can we use 200 megahertz and the divider by 4 and do something else on the GPIO stuff? Will it still work, or what happens there? Did Sandeep respond? I lost track of all my... Wait a second. Let me check. All this. Where is it? There. Oh, he did respond, yes. I have not. The Ethernet Pi module I was using did not support an input clock signal. Would have been much easier if it did. Oh, okay, cool. Makes sense. We managed to use we'll just update him. What we did right now. Oh man, so many windows. I get more and more in windows right now. Wait, what? What do I do here? This is a 9. I don't want a 9 there. Okay. I don't know if we should tweet like yes, I mentioned that we are, and Dave, I think, did Dave? No. Maybe I should link the the actual stream. If I ever find the window where I'm streaming, where is the window with the link? Ay. Here. Okay, it's casual and barely anyone is awake yet. Or not yet? What's the anyone is still awake? Or okay. Maybe ask him best way to contact him further. It might be interesting. Like, Okay, he doesn't follow me right now. Oh yeah, it's... Is it so late? Yeah, but oh, it's early in the morning here already. So I will keep in touch with him, I think, because I really like maybe to send one to him, especially since he did so much work that helped us already. And yeah. Okay. Let's see what we got. Okay, we the next thing is, this is not what you want to see. You want to see the code. Okay, next thing is to try 200 megahertz, the divider of 4, and now we need to do something in this PIO. Is this the only place that we want to adjust things? What is this smconfig set out shift? That's shift. Shift is like 3-bit. No. Clock pins. smconfig set out pins. Pin 3. No, pin. Wait. Config clock diff. This is the divider. Let me check that. Clock divider. Oh, there is a clock divider int fraction. Oh wow, it's a float. Okay, yeah, that's basically, let's try 40 here. And this one. And this one. Okay. And see what happens. Oh, 2.5 equals 50 megahertz. Boom. Yeah, and we can use another PIO to generate the external clock. That would be like sick, wouldn't it be? And we don't even need to change anything. We don't need to mess with the main clock or whatever. Oh, that would be a thing. Use another state machine just or PIO to output a clock. Yeah, that would be a thing. Oh, do we have like... Did it work though here? Do we have like... Do we have here... It doesn't... Does it? Let me check. Do it. No. DHCP says there is a device, but I don't get the data. So site doesn't load, but DHCP says there is an IP. Okay, let me. Oh! Okay. Okay. Let's try again. Okay? It loads. It works. Oh, it works. It works with 200 megahertz. Yes! Okay. What next? What do we do now? Should we try the 100? Can we try? What? How about? This is like 10 megabit. How about we try 100 megabit? We just set the How about we just try to set it to 4 instead of 40? What happens if we do that? What do you think would happen? The Ethernet module is 10 or 100 megabit. Both. I don't know if there is something you need to do differently, or you just send at 100 megabit. We can basically try. Only thing that would happen would either the second LED turns on for a short time, or it turned off again. Sad. Huh. Why wouldn't it work with 100 megabit then? If we get like enough speed. Can turn this off, we don't need this. Okay, that doesn't work. That doesn't work. There is something else we need to change. That might be not enough. Okay, let's change it to 40 again. And see in the code what we need to do to change it to 100 megabit. Because that would be like It just has 10 megabit link before communication even started. It won't magically switch to 100 and blast it with data. Okay, so this is not where we go. RMII Ethernet. Ah, here. We disabled it. Auto negotiate. How about we not do that and try again? Yeah, we changed it before, so yeah. There is an auto negotiate, so that might actually be it. Oh, this would be so awesome. It's like no one of us would expect like 6 hours ago that we went anywhere in this stream and we proved everything. We did a new board that works with the protection diode, with like a backpack IC on an IC. Your dog, I heard you like IC, so I put an IC on your IC, so you can, okay. And we even changed it to maybe work 100 megabits. The 100 megabit LED is still lit. No! Look. It loads at 100 megabits. 100 megabit auto negotiate uplink. There's the proof. Oh yeah. Ah, this is awesome. This is awesome. I think it didn't work before when the main clock was 100 megahertz, 150 megahertz, because basically the data bus wasn't able to put the data in the RAM or whatever it's doing, and now that we have at least 4 times the clock, it's somehow capable of doing that, and that's what.
Hier ist das Top-Suchergebnis aus dem Netz.
Nope. And that's basically what's happening here. 100 megabit uplink. Oh, where is the music? Where is the music? Where is the music? We want the music. Let the music play. No. Here is the music. Ah, that's wonderful. Hundred megabit. How can we prove it? How can we prove it that it's 100 megabit? Tell me one thing to prove it. And let's do it this way. Have the code start a big download while throwing it away. Yeah, that's... We need something simpler. Command terminal iperf. Okay. What is iperf? Iperf. Do I have it on? Do I need? I don't have like this router isn't connected to my main router. So, oh yeah, I could use the laptop for that, maybe. Yes. What do I do there? What do I do there? But we don't have a socket connection. Don't we? No. We have like... There's like only... Oh, this one is still running. Okay, cool. I will turn it on. Hey, Simple! Yes! Yes, and... We are totally successful in wrapping up this project. We fixed... Oh, we didn't test the ADC like the voltage reference, but basically we measured the voltage there. So we changed the code to work with the internal clock of the RP2040, and it uses now 100 megabit uplink. I'm not sure if iperf server is part of this example. Clock it to a gigabit. I don't think that 1 gigabit, you need at least 500 megahertz to get 1 gigabit uplink. We need some serious liquid nitrogen cooling for that to work. I can check, maybe the router is showing what kind of connection that is. Network. Oh, come on, admin. UDP, I don't know. I can ping it maybe. Okay. I can test. Ping. Okay, I get a ping reply. So what's the comment that we want to use there? So what do we want to tracer? Oops. Trace. UDP. How do I grab? iPerf. Okay, let me check. Okay, I need to install iPerf. I will check iPerf. Oh, this isn't connected to the internet again. Okay, let me check for a second. I will try to get iPerf. Download binaries. Download iPerf for Windows 64 bits. Yes, please. Oops. Okay. iPerf and what now? Oh yeah, I need to change the Wi-Fi again. And now IP or what? Oh, iPerf 3. Okay. A new type of screen capture here. it tries to. So what do we have? iperf usage, hosts, client hosts, options. Okay, so client. Come on, where am I? Hyper3 and then minus C, and then it tries. Wait, I will switch to manual focus as soon my face is out of the way. Come on, focus. Focus. Oh, it focuses on the reflection. Thanks for nothing. Now, okay. Connection timeout. Okay. Is there a specific port 80? Port 80. Okay, I tried iperf just with the client, it didn't work, but let's try port 80. Timeout. Oh, yeah, that's not happening. How? Yeah, but okay, that's. Can I download? That's not. Is there something like wget on Windows? Why 5? It doesn't run. It's like a bare minimum compilation of the stack, the IP stack. Okay, there is a file that we can access. Okay, there is like this in our. There is an image, a GIF here. Can we perform like download it? Hello, Sion. Yeah. If you do stream like that, at the end you have a complete device working like on core frequency of 200 megahertz and actual 100 megabit uplink. That's what you get if you stream that long. Ha! WSL on Windows. What is WSL? It's like a marathon. Yeah, we got everything off our list today. There's like we would only need to like try maybe a potentiometer on the ADC. That's the only thing that we would need to try. Use Oh! But wget would tell us the download speed. Where's my uplink? What's the user? Oh no, failed timeout connection. Yeah, it's dead already. Or what? Let me test it. Come on. Or am I not connected to the right one? Oh wait. Which one is that? Oh wait a second. That's like the wrong one. I might have a new IP because... Which one is it? Ah. What is this? I have four peers, 4 clients connected. Okay, no. It's still on port 100. How we even connected with the right Wi-Fi at this point? No, that's the wrong one. I'm connected with the wrong Wi-Fi, sorry. Ping worked before. It basically just reconnected. I need to... But it didn't. I pinged it before. There is a ping somewhere up there. Yeah, no. I think it's... Yeah, here. Oh, you can see it? There is a ping. I don't know at what point my laptop decided to switch the Wi-Fi, even though it's turned off right now. Where's my... Okay. Binary output can mess up terminal. Okay, so we need output. Okay. Yeah, it didn't download here. It was like fast. I don't know. We need a bigger file, I think. Or we can change the code to basically serve a huge file. Okay, let's try iperf again. No, iperf doesn't work. Okay, no, iperf doesn't work. Yeah, that's all we got. Don't we? No. Yeah, that's all we got. This is in the library. Maybe you need iperf too. Maybe I just need like the router to tell me what connection that is, but we are like with a wrong router connected here. This doesn't tell me anything. Yeah. Need a big file? Hold my beer. Okay. File system. Oh no, that's not it. Try this, replace IP. Okay. iperf C minus FB, okay. Connection refused. Okay, let me check what we got there. Oops. Oh. Server specific, run server, write P client specific, UDP bandwidth time, 0 copy server. Isn't there like a basic reads the HTML file many times or something? No. Oh, that's the wrong IP. Ha! No, connection refused. Oops. Can't we use huge pings? iperf2. I need iperf2 at 2. Oh shit, I'm tired already. I'm slipping into different. Okay, then I need to download it if I really need, but it wouldn't help because it's probably not even compiled in. So what will it help if it's not even like compiled properly. We should basically like try a UDP client or something. And okay, I try iperf2 just for your satisfaction. So I have iperf2, which is the normal iperf, and I bet it will not work. It will not work. I bet with you it won't work. Just need to reconnect again. Is it connected? Yes. Okay. Oops. Connection refused. There's no difference in that. Oops. There's no difference. Connection refused. Okay. That's like, that won't work at all. Okay. Let's not stress it too much. Maybe we can see if there is something that we can link in that isn't right now. So what we saw here is current limitation built-in LWIP stack is compiled with no sys. So let's compile it with sys. How about that? If it but there is no firewall there is no firewall on the RP. You mean outgoing or what? Ping? I pinged it. Okay, I will ping it again for you, just for you, Aaron. You deserve. Here is the nice, juicy ping that's 2 milliseconds. Oh, the third ping is lost probably because... Oh, yeah, I had like marked my whole... Okay, the mean value is 2 milliseconds. There is no doubt about the connection here. and I can still curl the file. So file is like speed is 48,000, I don't know, bytes per second, but the file is not that big. So actually, yeah, I think we should basically try to see if there is like test source, not apps, cmake. It's not cmake, file list make. Where do I change the configuration? Is this like in the make files? No. Okay, let's seek with find the, no, not here. No sys. Okay, let's make it contain. Where is it defined? No sys. Oh, here we go. No sys. Okay, we can DHCP, auto IP, DNS, check IP. Is there a flag for this? Maybe we can iperf. I don't see it. Oh, you are seeing only the table. Oh, sorry. That's like, woohoo! Yeah, that's where I am now. So this is like, there's no sys. I bet it won't compile if I. That's a lovely table though. Yeah, I made it myself. I just got like a like this plate, wooden plate from the hardware store and oiled it. Added 5 legs and that's it. What happens if we compile it with this? Run, try it again with P minus P5001. Oh. Connection refused. Aaron, sorry. Connection refused. Or do I change the window again? Okay, I compiled it with this whole socket, whatever. No. Hello, Luminator. Yes, we have like a successful 100 megabit and with our nice and sweet Raspberry Pi RP2040 running. Everything is going on, working, and everything is nice and dandy. And now we try to do more than just serving this side there. But how can't there be sockets? Must be sockets. How would it work? There must be a socket. It's connecting to a socket if you are using like. Oh yeah, but that's like it's running it in. Yeah, it's running it as a SD card. What you suggest here? Not SD, like an USB network card. So can we like? Oh wow. DHCP config no. Perf. I won't do that. Before I do something like that, I would rather enable sockets and transfer a huge file, like a random bytes. Sion, you are funny. Okay, I think this is none of my business anymore. I compiled the code now with like the. How do I access? Let me check one more thing. We have this one X like Pico DHCP. How do I do? Let's check. Is there a test? Sockets. Socket stress test. Can we just open a socket server? Oh wow, this is, can't we just have like a simple example? Not a test here, like examples. Okay, I need an example, a basic socket example, so I can set up. This isn't what I'm looking for. No, this is not a. We can actually post data to the. Oh, that's interesting. Yeah, that could be. Okay, so we need a huge file. I just, let me get a huge file first. And we will upload a huge file, or post a huge file. Okay, I have like, let me check. There should be like a video file. I just take any. Okay, this is 1.3 gigabytes. Okay, yeah. So curl or curl. I will just, I have like a 1 point whatever big file. It will be like 10 seconds at least, so it should be fine. Let's test it. But it's the highest speed I can achieve is actually the Wi-Fi speed here, or I need to use like my network adapter, USB network adapter here. I need to copy -F. Do I need this add path or just path? Empty reply from server. I think. Well, server closed the connection. It basically doesn't accept any post. Can we just get with like a huge... No, there's also a limitation to that. Okay. Let's finish it for now. Oh, more verbose output. No, it doesn't allow like boundary. Okay, no. Okay, let's finish it. Okay, we will do like, we can do another nice stream, or if at some point what we wanted to achieve today has been achieved. This is completely working. It's working better than expected, beyond our imagination. And here is the music. We will follow up with a socket server quite soon, where we will communicate. Dance time. I'm too tired. Woo! This is 100 megabits. It's 100 megabit because there is an LED that's lit. It says so. It's 100 megabits. Yeah, he will. Good night, everyone. Thanks for your patience and your help today. It was a blast again. I wouldn't expect that we are so successful with such a like slow start today. But the fondue kept me alive. Thanks for the fondue fund. Bye. Big man. See you next time. Bye.